Hello, everyone, and welcome to the broadcast. I am newtmechanist, and today we are going to be continuing our game development project. We figured out one of the things that wasn't working last time just after the stream, and we will be continuing after from there. Probably gonna regret touching this button, but I'm gonna touch this button. Before we get too much further with that, let's check in with the kitties. We do have Sammy partially visible on the table. I am seeing a lot of stutter with my camera. Isn't that great? But it should be okay. Should be okay. Hopefully we don't lose too many more frames. I am going to poke something with that. But we'll see. Yeah. Gonna poke something with that. We're losing about 6+% of our frames at the moment. Might level out, but we'll see on that. Anyway, we have Sky up in the tree, and we have Ember sitting on the bed. Sherbet was briefly visible over at the food dish. I don't know where he has. Oh, there he is. He's under the desk. Oh, let's see here. We are gonna refresh this again. I think I need an update to a plugin. We'll see. I have to try to keep my eyes on the other chats. Might be holding. Okay. So, when last we met, it's so fiddly. Sorry. The vtuber scuff is real. We're holding steady on both of these. We should be okay. Might have an issue with VTube Studio. Anyhow, just a moment. We'll see. As long as it stays low, we should be okay. But I apologize if the frame drop gets noticeable. Okay. When last we left, we were messing with the tile load. So this is a brute force set up the what would it be? Kind of the auto drawing logic. So with a tile map, generally what you try to do is set up adjacency rules. This one doesn't have all of the rules in place yet, but it'll do for now. What we want to have is a fixed way to set the adjacency on all of them. Once I have the final map, what we'll do is have some rules for while we are generating these tiles gracefully. So I may just port this over. It is it is a brute force way of setting it up, but that's kind of what we're gonna do. Is based on which tile we're pointing at, we have a neighbor logic here. Right now, we've got it set to the corners of the square. Actually, let's pull this up. We will show what we've got in just a moment, but first we need our data, we need our textures, we need our map textures, and we're going to pull up the A-sprite for that. So here's a background test. This isn't a complete tile map for it, but we have what if it's a 3x3 square in configuration, what if it's a plus shape, what if it's a ring shape. There are a couple of others, like what if it's a column, what if it's a row. That kind of thing needs to be accounted for. Hey there, Twice, welcome. We are just getting started. I was explaining our tile map layout for the time being. Saying there's more to this we need to set up. There's more configurations that are kind of standard layout. But we'll see. Like, we don't have tile on corner next to tile. This one doesn't really need that, but I'd like to be consistent across all of them, that there is a pattern for like the two points on the cross, the left and the top. What if the center is missing? That usually puts some sort of little join in the center. But so it would be, usually you have some configuration for it such that it is, it doesn't have an open side on it. But we'll see. We'll see. We might just make it so it's like a standalone if it's that case. And right now it would be. Anywho. So that's what we're working with. Let me turn the music down a little bit for you. Leave it like that. While this is a programming and dev stream, one thing to keep in mind is that I have never done a major project in C# before. I've done projects in other programming languages, so it's not a big leap. I have never done a project in Godot before. I've never made a game before. But we're diving in kind of, it's still into the shallow, it's kind of the gap between the shallow end and the deep end. So let's get our project here. So we should have some tiles in the upper left corner, I'm sorry, down and right from the player. Right there, there's 16 by 16 tiles, and we can see the 4 corners set up. And we could do this with more of them. And that's what we're working with today. Can show you what we had to do to make this work. So here is where this whole mess here is where we are setting the tile layout. And to do that, you have to retrieve the tile data and then set the peering bits. The tile data was one of the tricky things towards the end. It's really bugging me. Really bugging me, and I don't know why it do this. I need to figure that out. Is there a toggle for this? Is it a toggle here? Is it a toggle somewhere else? Don't know if that's what we're running into. Fine, that's fine. All of that should be okay. Again, vtuber scuff here. We're having some issues with it. But I think the problem is on the VTube Studio side. Yeah, there's some hitches there that I don't understand why they appear. But they are. It's like we're losing a second of tracking now and again, and it weird. It obnoxious. But I don't know where the actual issue is occurring. Oops. Boop. We'll see if I can fix it. We'll see if I can fix it over time. But for now, we gotta continue. Yeah. another thing that I need to ping on. And is that better or worse? I don't know what doing that. Like I said, it is very much VTube Studio at the moment, and it's not clear why it's doing that. So this might be something that I am poking as we go. How did we set that? Anywho. Hey there, Schmuggums. We're having a good day. We do have some issues with the software at the moment. A bit of a bother. Let's see here. Hey there, brah. I'm trying to poke something here. Higher priority there. That we need to catch here. Strange, but I guess maybe it needs more there. Hey there, Yopie. And we're gonna do this. Okay, well, hopefully this will help things a little bit and not hurt things. We'll see. Real-time investigation. Well, it's still not helping. But, okay. Oh, okay. Molly found some cardboard to chew on. Okay. Doing well, Yopie. Doing well. Like I said, some technical hitches still with one of my programs, but we'll see how we do. Last time, towards the end, with some help from Laura, who has been messing with tile sets prior, kitties are doing okay. Pretty much as per usual. I use an iPhone. It's kind of optimal. It has some really good... The facial recognition software that's built into the iPhone for, like, face authentication is also really good for tracking data. Wonder if... pretty much the reason that I use iPhone is because of this. Why do you do this to me, software? Why do you do this to me? Not that, that. I don't think an iPhone 10 works. It's got to be like 14, I think. Not that. It's not that it's not supported. It's that it lacks the camera interaction. That we have that. Okay. That. Let's see. We have somebody new in the channel. Neon, I suppose. Welcome. I am doing some ad hoc debugging, so forgive me. Here, we'll put something on the screen. The thing we're going to be working on today is this little tile next to us. While I do this, feel free to chat or ask questions. I will notice. That's too many. It'll lag the system, but should be able to hold it about that. But trying to find... we're making a game today. Or we're doing our game dev today. And why is it doing this? Yes, yeah, it is a Vampire Survivors-like. Our gimmick is this, where the weapons are going to be configurable. Instead of leveling up the yarn ball, we are going to be getting kind of upgrade modules for it, where the sequence in which modules you use are going to determine how well the weapon and overall your build ends up working. Why do you do this? With that. Again, we're having some technical difficulties. Should have an output. Is it that the later versions don't have? Interesting. I'm going to have to check for a new version of a particular plugin that I use. I'd be interested in playing Ultra Kill. I don't recall which one that is, bruh. But for example, right now we're setting it to spiral out, so it does little loop-de-loops. If we do this, it spirals in, so it will attempt to orbit inward into a circle, which will look kind of like a dome, given how the yarn balls behave. What we're seeing right now is kind of maximum performance drain at just under 1,000 things in existence. If we reduce that number... I don't know if I'd end up playing that, bruh. Generally, we go for particular varieties of game, let's say. Right now, the two that we're looking at game-wise for the game streams are Blueprints and Hitman 3. We're going to need further performance as far as map rendering. But we'll see where we get. I do want to do a quick experiment. Map renderer currently sets up its tiles. So we are just going to return here. This is where we do all the footwork for it, and where we would add the tile as a child in this. So we get all the way down here and we put the child there. I want to check immediate performance because we may be staring down a dead end at the moment. Okay, so that is about 1400. So we do that. This is with... it doesn't cost us anything, really. Does it? No, that should be okay. Okay. It's 1100 as we get them reaching us. There's definitely some sort of drain going on. This is not the frames per second that we're targeting. You know, over 1,000 is unnecessary as far as raw rendering frames. We've got it unbounded at the moment. The blobs would normally hurt you. They can't right now. Okay, we're still well within reasonable territory. We're going to up the number of things. I just want to see where we currently stand. Still good. We're at about 200. I would like to be able to get 700 without the frames per second dropping too low. About 700 is the screen is filled with things. More things than we need necessarily. Just a second, we are going to do a quick bit of napkin math. That, let's call that 68. Okay. Truly filling the screen would be that. For doing some quick calculator work here. Okay, that would be filling the screen, would be about that, so... Okay. So, it's... I would like to be able to get, like, 1,000 entities without the frames per second plummeting below our limit here. And... yeah, we're only getting like 16. We still have optimization to do here. What a big part of what this is resulting from is the footwork that Godot has to do in order to deal with creation of nodes. If we have a Godot helper somewhere, we are getting derailed. We go into node cache. So we're going into buffer add here. That is our that's where it will increment. And we drop back down to adding minimum anytime we release something. You would probably run out of resources very quickly, Schmuggums. A big part of the latency is maintaining the system. Okay, we don't want to cache the system here. Like, we don't want to just get rid of them. So we are going to try this. This will mean that we have, we'll do this with mass ones. There we go. Easier to undo that. Who's crying over there? Okay. So anytime we try to load something, we increase the size of the cache, and the cache never decays. So once it's in there, it's in there. What this will mean is that as we go along, the cost of adding things should go down. Because we can control a lot of this, and this is way too many projectiles in existence at once. But again, I would like to be able to have like 700 while still maintaining a reasonable frames per second. I don't have a good way to speed it up further here. Like, we could do this. Something. Yopi, right now the ball is circling. And that's way too bad for performance. There's more footwork that we need to do. So we might get totally derailed today. Okay, so this didn't really help us. So if at any point we release a node and we're above cache minimum, it goes away. And we slow down the add. I don't think this is really helping us. So let's see. Node physics. Doesn't help us. That's a basic attack, Yopi. The way the ball is moving around, there's going to be some series of weapons that you can get access to at once, and then upgrades for them. The number of them is way too big. So we need to make sure we're checking to handle the number of things. So we have a lot of enemies that are going to be appearing. We have a lot of projectiles that are going to be appearing. We need to minimize the load of creating and maintaining all of those projectiles. Because right now we're trying to use Godot nodes for it. We could fall back on custom collision detection. Especially given that we've set it up to be collision on their shadows, which would be at most capsule detection. But that's still not free. Let's see. Process mode enum dot. So what this is doing is it's disabling the node when it's cached. And then when we're ready to add it, the node that we're returning, we turn it back on. So that parent node stops processing. So let's look at this on the Godot side. I want to look at a disabled node. We are derailed by performance testing here. You can see those little blue circles. Maybe you can see them. Are the hitboxes for the things. Okay, so we have all these entities in existence. So we're going to open up core, then game. We're looking at the collision space manager, and it has a series of nodes. What do we have here? So process mode is disabled on this one. What if that we need physics 2D, common physics, so we have 60 with up to 8 per frame. We do 2 per frame at the moment. Let's... this will technically even out the physics, but it shouldn't matter from a rendering perspective, really. Let's turn off the collision debugging, actually. There we go. Those little blue ones will cost us extra performance when it's running, so we want to remove that. We have also removed the tile map from our rendering here so that we can mitigate as much as possible. Okay, our 800 range still has us slowing down a lot. Again, this is a whole lot of things. This is a whole lot of things. If we cut it down by a power of 3 on the projectile, now the frames per second doesn't jump back to its upper limit because there is a cost to going up that high that sticks around. That is that cache. That cache does decay over time. What we're doing here is we're going up, coming back down, going up, coming back down, seeing how well it recovers. Yeah, I think we're reasonably recovering. And we don't need too many things on the screen at once for the player to effectively become invincible. Like, here. So we're spiraling them out, and we're creating an explosion under each projectile every second. So here's with 300 some things on the screen. They move pretty slowly. We're getting a little under 30 frames a second. Let's say about 20. So now we're going to cut it down further. To be clear, that's X things on the screen, but those explosions exist and go away very fast. So this state right here, it's very hard for the player to lose. So I'm not too worried about multiplicative setups like this. Make it more complex. So technically, again, the number of things that are springing into existence, very briefly, is actually much higher now. Whenever these explosions appear, they're appearing 3 and now 9 at once. So we can hold at a pretty reasonable number of things. Now, the yarn balls currently don't function as I would like them to. One thing that we can do with the yarn ball would be to make its collision zone actually very big with a particle effect when it hits the ground, because that's the goal of the yarn ball, is that when it touches the ground, it hits things around it. It needs to do that if it's going to do its fly through the air behavior, because as it stands, it does not protect you at close range at all. And it's kind of erratic where it will hit. The bounce is at a consistent interval, but it's going to leap over things effectively. Okay. So the yarn balls are the more expensive aspect right now. Simpler behaviors are also cheaper. The spin around the player is relatively expensive. Okay. So for now, let's resume where we were. So let's put our map render back into play. Just so. Okay, so we're going to... So we have create tile map layer. We're going to have a protected void. is a tile set, and then all the way down here. Yes, it is a tile set. So this is a single tile set. So we're going to get a texture wrapper here. We're going to start with just this here. And this has to return a tile set, just so. And we'll call you tile set. Now, what we're going to be doing with the renderer is we're going to be setting up, when a level is loaded, we're going to store off a bunch of this stuff. Because each level really will have its own kind of tile atlas that it works with. And once we've created that once, we don't want to do it again. So we'll see how we do here. Check a couple of things here. Okay. Okay, so we make a tile set. We have our tile set source. And then we are loading the tile set here, and we add a source to it. So tile set is one thing right here. Where we're adding terrains to it. So creating a tile set needs a tile set source. It needs potentially a series of tile set sources. To create a tile set source, that's where we're creating the tiles. Those if statements are a brute force. I don't want them there. We are going to need something similar to that. Let me. They do look awful, Eunice. They pain me. So what we're dealing with is we go into this. We are going to look at our tile set. And then we are going to click one of these little guys. Where are you? Select. We select a tile. We're going to go to our terrains in our peering bits here. These are resetting constantly, but this is... There we go. So for terrain set 0. This is what we're setting. This is for tile drawing. So you can go through and say, if this tile is adjacent to tiles in this fashion, this is how we do. So, layer, select that. We are going to go into our tile set. I need to figure out what the button is for this. I avoid using the Godot editor if it's not apparent. Okay, it's not that. We're going to select. Select this one. Can we paint it? No. Where do we do? Okay. Can I do that? No. I haven't got it configured correctly. Selected you. Well, let me just demonstrate. If I were to have corners like this, if I drew 4 of them next to each other, it would look like this. If I drew, again, I don't have all of the configurations here, but yeah, I don't have a lot of the configurations here. We could do multiple of them so that we get these different patterns. That's what we're looking to do here, is set up what those patterns are. So when it's got one on its left, but it doesn't have one on its right, and it has one above it, what does it look like, kind of thing. That's what we're going to be configuring. And because of that, we need to set up the grid accordingly. So right now, our tile maps are always 6 by 6. This will change. But each one of these has its own hearing bit layout. And to set those, this is an unfortunate aspect of how Godot handles this information. We set up tile data. And that tile data has these bits configured. Hey there, Sid. I'm going to guess it's Risen. It might be Ryzen, but welcome nonetheless. And welcome, Eunice. I forgot to welcome you. So we need to set these peering bits. And they are set individually. By default, it's -1 if you set it to anything. I'm sorry, if you set the bit in that terrain, it is essentially saying it looks at that. So the tile data for a given tile, so we create a tile, we extract the tile data from it, and then we set its peering bits. And that's what allows us to paint it on. Then, subsequently, again, this is all as we go code. This is a mess that we need to abstract out a little bit more so it is legible. But sadly, this kind of layout is actually going to be close to necessary. We might be able to create some static functions that say, given some tile data, set it to this property. And it would amount to, like in this particular case, about 36 different possibilities in it. And that's kind of what this if-else is those 36 different possibilities. Every one of these that isn't blank, that has the darker gray tile in it, has its own configuration. Now, we only do this on load, because otherwise it would just be a mess. And for reference, this layout is generally not what you use. I don't have a picture of what you generally use, but you normally have a row of 3, a column of 3. You have a series of diagonals. That kind of thing. So right here I have a cross. You'd have the equivalent of an X. And similar things to be as detailed as you'd like to be. Risen, my model was done by Animashit Studios. It was that at the time. I think it's Kuramash now. I believe the pronunciation is not what I think it is. They did a good job. Beverage. But for now, we're just configuring this 6x6. So I am going to steadily pull this information out. So that each one of these textures that we create, we are going to say, this is a tile set source. Oof. Okay, no. What we need to do is to create an actual atlas texture. And that atlas texture, whenever we add a new texture to it, we define a region of that texture to be the one that contains this, as well as which terrain it is. So, in practice, there's going to be multiple of these. In fact, I can do that. So we're going to... we're going to make this the red layer. And we need to create a transparent mask here. Fill. Set an alpha on this. Okay, that'll do. Okay, and then we're going to grab some red. If you're curious, this software is Sprite. We'll increase that opacity. I am by no means expert at using this stuff. You will fill that in. Escape out of that. It's our marking tool. This. I don't have to be this precise, but it's kind of useful. I'm doing this so I have 2 different textures that I could load. Okay, so then we are going to duplicate this one. And we're going to call you blue. I'm going to hide you. We're going to sample that. That's our red. We're going to take an arbitrary blue here. We'll make it blue. Sample that. And we are going to That should have... There we go. Okay, we'll take that and then boop and boop. There. Okay, so we have a gray, we have a red, and we have a blue. That technically means we have a purple. If I throw green in there, we can get pretty much everything, kinda. Okay, we're going to make you red. As... Okay. We close out a U. This now gives us red and blue ones. Just so. Now we need to go to our data folder. We're going to look for map or map data. Okay. We're not loading a map data. We're loading a map. This is... I should name the I should name these something different. These are tile sets. And these are texture wrappers, is what we're loading here. We'll call you red, we'll call you blue. And in the same way, we have red and blue. Okay, so we have the 3 tile set textures now. Right now we are we're using get texture, and we're loading them in. We are going to we want to stitch these textures together with some knowledge of how it's going to play out. Because when we're setting up our Atlas source, what we can do is we can create a sort of super texture where we create we load multiple textures in together and iterate over the number of tiles in it. Now, ideally, we keep the texture as compact as possible, but for the time being, we're going to stitch them vertically. We did something like this elsewhere. So if we look at the shader renderer, so this is our visible map image. We create an empty one, which is going to be the size of the number of textures that we're passing in. So this is where we would know in advance how many we're adding here. What are we doing with extra blocks? Hard-coded that to 2. All right, so again, what we're planning on doing is we create like a super texture. And we take all of the textures that we're going to load and we put it together with that, with the data for this map. We create a tile atlas from that. And then we load in tiles for each one, using each of those as a different terrain type. The terrain type in Godot terms is a set of tiles that are kind of the same entity. So game mechanics wise, you could say, oh, this is a road or something like that for a terrain type. But image wise, it's also for creating those kind of merged textures where the blocks kind of flow together based on the setup. I'm refreshing my memory on how this works. Okay. This is the whole thing. This is I'm looking at the wrong function. It's not visible area that we're dealing with here. We need the tiles, like the actual tiles themselves. It's our world map. It's the map texture. This was us setting up. So the code that we're looking at right now set up a shader that would render the map onto a visual area. We may return to this logic, but this is a very particular way to do the map. Again, we may come back here if the Godot one works. All right, bacon. Oh, well, let's... was trying to refresh my memory on how to programmatically create a texture on the fly here. So we're making Vampire Survivors style game. The gimmick of it is going to be that instead of the weapons being pre-designed, they have base behavior. So the little yarn ball thing flies up and bounces. It's terrible for a weapon currently. It's incomplete. Yeah, the enemies converge on you. I have removed the behavior that makes them hurt you when they touch you. They're there just for target practice, essentially. But we can change the behavior of the projectile by adding these modifiers to it. So, what would be a good way to put this? So in many roguelikes, you get upgrades periodically. So it'll be like a relic or something like that. And it makes your character behave fundamentally different. Yes, it's like program your own weapon. It's very much inspired by the game Noida, games like Bioprototype, that kind of thing. And we can do a lot of different things with them. These are kind of micro upgrades right now. They are not a whole thing, but they demonstrate the patterns. So we can make them move differently. We can make them move really differently. Or even more so. Some of these are more likely to be things that you would see... how would I put it? They're more likely to be things that would be the base behavior of a weapon. Like this weapon fires in a fan of 3, always. Anything that multiplies the number of projectiles is likely to be very rare. Because we can create real big performance slowdowns by making too many things that last too long. So right now, those blobs don't go away. They only go away if they don't go away naturally. The bullets do. They'll time out. So we accrue more and more and more of them. The blobs can overlap. That's largely because making them not overlap is performance intensive. But this is the gimmick. It's you make weapons that have behaviors that you adjust over time. So in this example, this one, and our shorthand for this is that it's got the blue bar instead of going to the right goes down. What this one means is it will consume this second weapon, the one that creates the explosion, and it makes the first weapon emit it every second. So every one of these bullets every second creates an explosion now. Again, the yarn ball is the one that we currently have set up as our test weapon. It's not a good weapon for demonstrating hitting the enemy right now. Its collision deal damage concept is not finished. But what it does is it demonstrates the z-axis. It demonstrates things being in the air in the game. And things in the air don't interact with other things. Even other things in the air. We're not going to get complicated here. We're not going to add the third dimension to collision detection in our 2D game. How do I plan to make it performant? So right now, we have about 100 things... 150 things in existence in the game world. That means probably something like, let's say, 600 Godot objects. We are doing 60 frames of physics per second, and right now we're rendering at about 470 frames per second. The visual frames per second is just a performance indicator for us right now. That is not the planned finished value. If we amp it up another step, let's increase the number of yarn balls by power of 3. So now we're reaching about 200 things. We've dipped down to about 177. Let's give ourselves another power of 3. The method that we're using right now is stress testing. This is a you win state. If you have this weapon, you are undefeatable for the most part. The health system in the game is hits. It's not arbitrary numbers, so it's not like they do 10 damage. They do 1 heart of damage. The blobs currently have 1 heart of health. that number will vary, but even if the blobs took 3 hearts of damage to bring down, it's mostly yarn balls in existence, and each one of them every second, while it's passing through the air, does 1 damage to every blob that's within a radius of it. So this scenario, the upper right one is frames per second, visual frames per second. Again, 2 physics frames are being rendered for every visual frame. I am going to change it so that a physics frame is always a fixed amount of time. So whatever our default frames per second is going to be, that is also going to be the amount of physics per second. Even if the game slows down, it will always tick at the same pace. So if the game slows down because of how much rendering complexity is going on, the game world will move at a slower pace, so that you don't get weird physics anomalies because things are slowing down. You get some of that because, again, physics frames per world tick, but physics frames will also receive time since last physics frame, and we don't want that to vary too much. Like I said, this is an I win state. It's really, really hard to lose when this goes on. We can see demonstrated here, the movement is modular. So it's trying to orbit the player. The yarn ball gets drawn into that circular orbit, but it's not orbiting in a fixed fashion. We don't say the yarn ball is exactly here. So as the player moves, the yarn ball has to try to keep up, but it doesn't really accelerate to keep up. The yarn ball technically moves faster than normal in order to handle the rotational movement the way it works. But we can see that they drag as we move down. The ones on the bottom side have to move further horizontally to curve up and get on the right side. But at about 500 to 600 things, we're under 30 frames a second. If we then drop way back down, we are planning on running on mobile. Let's see, which do we have it configured for right now? Right now, that's for mobile compatibility, is how the executable is set up. So all of the logic in the Godot side, this is running with mobile mode. If I set it to forward plus, we'll show it in PC mode here. Once it reloads. Okay, so this is in forward plus, which is the optimized for PC. And I do not pretend that it's fully optimized yet. We do actually spend a whole lot of time trying to tweak for performance. We've tested a lot of different ways. It's as much that it's not capping the hardware, it's that the game engine is working much harder to accomplish the same stuff. So you can see we can get a little higher on the PC side to some extent, but it is an extra optimizations thing. Because all these little guys are doing movement per second, all of the things are doing collision every time they move around. It comes down to how can we render them as efficiently as possible. But that's what we're working on here. This is a reasonable amount of things on the screen. We've got every second we emit 27 of the yarn balls, and they live for about 10 seconds. If they were colliding, they would be stripping more of the blobs out of the way and potentially going away themselves. Like I said, there's still more tuning that we need to do. There will always be more tuning we can do, but I think there's more that I want to do to get it tightened up. But we're attempting to get it to perform as well as possible in the most extreme cases. Where's our visual? It's not there. It's not there. I wonder if there's a way for us to get shadows without having to do it the way we're doing it. That would save us another Godot object. I mean, if we can keep it running at 420 frames per second, yeah, that would be... that would still be pretty good. We have experimented a lot with shaders for the for performance purposes. Yeah, it's... So, Vampire Survivor style titles, their very nature is rough as far as how they perform. Where is this one hiding? As far as more contents, one of the things I'm also trying to do is make the game as moddable as possible. Is everything is loaded from the CSVs at startup currently. CSVs and JSONs. The CSVs get turned into JSON. They're CSV so that I can maintain sanity in editing a whole bunch of them instead of having like brackets and brackets and brackets and brackets, you know? So we load all this stuff up. One of the things that we might, if I stop getting distracted, letting myself distract myself, is the map rendering. Part of the map rendering is creating tile atlases from the stuff we have. I don't want to need to compile them at runtime, but catching them at startup and doing the footwork to create those at startup means that I have an incredible amount of flexibility. Where do they keep that setting? For those curious, I'm trying to find the setting that throttles the visual frames per second. Would I want to use this? Like vertical sync mode you can have on iOS parameters. configuration for Godot can be a bit fiddly. Part of the other thing is we don't necessarily need 60 physics frames per second. We could say 30 physics frames per second. So you can see, well, I can clearly see the stream is at 30 frames per second, so you might not be able to notice. But there is a definite difference in the smoothness of the animation at 30 physics frames per second. But since we have halved the amount of processing that we do per second, we are sitting at just under 1,000 things at 100 frames per second. So we might just do it this way. And tweak how we do the animations in similar. But again, so here's about 1,000 things. Let's bump it up one more so we have 3 to the 5th yarn balls being emitted every second, and each one of those will live for about 10 seconds. So we are sitting at 81, 243 per second. So we should get up to like 2,500 plus however many blobs we get. The goal is to have frames per second, plural, at extreme cases. At calamity cases, what I refer to as the game is strained beyond measure, I'm fine with it being sub-frames per second, seconds per frame. Again, Noida was a big inspiration for the weaponry in the game. We used to play that a lot on stream when we only streamed on Twitch. I think there are still some Noida streams on on YouTube. Shameless plug. Watched my old streams. And one of the things that we would strive for, we modded Noida heavily. One of our goals was to get to the end boss and one-shot it with the biggest, nastiest explosion we could come up with. I think the longest delay between game frames was about 5 minutes in order to register a attack that did multiple quintillions of damage. I'm not familiar. What's ECS? For a while, we were trying to do everything on the shader. Entity component system. I will make a note of that and strive to remember. Think how we would wrangle that to clean it up. Would that be possible? Okay, so the difficulty I can see in that pattern. Yeah. That's the difficulty that I can see in the pattern, is that if I had fixed motion and sequence of motion, then it would be practical for me to go in and say, this bullet operates in this exact sequence, so it hits these exact components, or these exact components act on this particular entity, that kind of thing. But it's possible for me to have multiple different patterns set up on this thing that would make the logic, I think, equally complicated, and a great deal of our time is spent setting it up so they do what they're supposed to do. So, for example, I have made fewer yarn balls in more explosions. In fact, I've made way more explosions, because every second, every yarn ball, and 27 yarn balls emitted a second, living for 10 seconds, so 270 yarn balls in existence at all times, emitting an explosion every second. And each of those explosions is actually 9 explosions that explode on impact with an enemy. They would explode on impact. That does nothing because there is no subsequent weapon. But if there was a subsequent weapon, they would emit that weapon every time they hit. But if you look at this, this is an I win case. It is very likely that every blob would take like tens of damage per second that it enters this this field of doom here. And the only way that the player would be threatened is if they have to move, because now the spiral pattern has to stretch and distort to catch up with the player. But if I had access to that and knowing that, instead of spiraling, I'm going to make it do loop-de-loops and S-curves. So now, instead of emitting in a circle around me, it's going to be this blast wave. Now, that doesn't work as well, because now I'm outpacing my projectiles. Because again, the orbit makes them speed up. They are technically faster when they're trying to orbit you. There's a little bit of a movement boost to account for the fact that there was expedient math that went into the orbit the player logic. But here I've created more and more curvature to their movement path. So as they're going around, they cover more ground. Within reason. And this is the gameplay. Is I got a power-up that makes it move in a particular way. Is that worth the fact that it makes enemies light on fire? Is that worth the fact that it explodes when it hits them now? Because that extra movement could give you vulnerabilities in your coverage. And if you don't have sufficient coverage against the enemies, then you're going to get overwhelmed and you're going to lose. Like I said, again, this is a stress test case. This is not like end state gameplay. But it is reasonable to have, say, this. Not this part. Not the second one. But the yarn ball fires in a burst of 3, explodes periodically, and tries to orbit you. This by itself is pretty potent. So just getting this weapon here, even if we pull all of these out, just this weapon is very, very potent. And that's kind of the math that we want to create. That's what we want the player thinking about constantly. What is our... It's worsening somehow. Huh. Well, someday I'll figure out why it do that. My avatar keeps hitching. At least it's hitching on my screen. I don't know if it's hitching for you guys, but it looks like it is. Okay. I think we'll leave it at 30 frames per second right now. Given that it's a pixel game, I'm not as worried about the motion being a little chunkier. Or at least the animations being a little chunkier. We'll see. But quick break, and I will return in a couple of minutes. And a beverage here. Moment, let's check in with kitties. All right, let's see. We could see 5 of them for a moment. The 5th one that just left should be returning to the bed camera there. Yep. Where is the 6th one? Not in any of his visible hiding spots, so. But we can see Molly in Sky in the tree, and we can see Mason, Sammy, and Ember on the bed. Set it to the tree camera there. All right. Okay. Let's actually set us back to... I can't remember what... I think... Yeah, there we go. Compatibility mode is use GL. See, it took way less time to switch back over to that mode. Okay, and we are going to... And yes, I always get distracted doing performance testing on every stream, but we do usually accomplish some small fraction of what we set out to do on the stream. Okay, at about 2,400 things on the screen at any given time, active world entities on the screen, which means way more Godot things. We are at frames per second, let's say 5. So let's cull ourselves down. We will not regain all of our frames per second since we went up this high. There are some resources that take a while to reclaim if we get this far. And so we're at about 900. And that's putting us at about 50 frames per second, visual frames. And then let's drop ourselves back down to 27 per second. Fading down, yeah. Okay, so somewhere between... if we can hit about 700 things, I believe that is the... it's less than that. I'm sorry, it's more than 700 on screen at a time. But that is the you are losing case in Vampire Survivors. That is probably the max amount of things you can see on the screen at once with their kind of movement and collision system going, where the entities don't overlap, but jitter around like crazy. With the player projectiles, so I would assume somewhere in this range, maintaining greater than 30 frames a second at this number of things is kind of where we want to be, I think. Okay. So, what we want to do next is we want to break up our tile set and our tile set sources and our texture loading into some layers here. Hey there, Ghost. Welcome. Okay. So there's going to be a list of texture wrappers. We're using a list of texture wrappers. It does not need to be actual texture wrappers. We could just use the texture 2Ds. Hey there, Ames. We're trying to get back on target as far as what we're coding. I got derailed looking at the performance numbers. And for a while on my software failing on me. I need to figure out why that do. Anyhow. I think it's a texture 2D. So well, I mean, we're using Godot, so we haven't started from scratch, but yeah. It's not the visible map. How did we do that? Right now, what I'm looking at doing is when I load in the textures for the world map, I want to stitch them together into one big texture that will act as the tile atlas for the entire map, so that when I'm rendering the map, I'm only using the one texture, so that the graphics card ideally is not swapping textures as frequently. Now, I don't know if this will actually help. Well, or how much. But my understanding is, as long as we don't go overboard and get the texture too big, then the handling of it should be cleaner. It's not the visible one. So the visible map was a trick that I used for loading the stuff onto the shader. All right, thanks for swinging by, Ames. Yeah, Ghost. It's kind of like that. We want to make it so that when we are referencing a texture, we're not referencing the file that is that one specific tile map. Instead, we're saying, okay, here are all of the tile maps. We're going to glue them together. And when you're referencing this tile map, what you actually mean is the region that starts here, on this point on the super texture. Hey there, James. Welcome back. It's not that one. It's not that one. I'm reviewing our logic that we used for using the shader to render the map. And seeing if I can find the spot where I create essentially the tile map that we pass into the shader. Here we go. Tile texture atlas. World map. Initialize. Yeah, okay. Okay. I believe that's not accurate. It's 496 is the max. $40.96. At least as far as making it so that the graphics card can handle it efficiently. Okay, so we create an empty one, which is as wide as we need it to be and as tall as we need it to be. Pixels in the ground sprite texture, and how big will the in-game chunk be if you can define the texture as an individual block? So we don't want the world map texture to be too big, because that really doesn't help us. Let's see, put it another way. the tile map for a given piece of terrain is going to be bigger than... It's more than 6 by 6. And each tile is 16 pixels. 16 by 16 pixels. So let's say 6 tiles by 6 tiles. Then let's assume that we're going to have at least 10 chunks, 10 tile sets. So we have essentially 360 by 6. No, I'm sorry. 60 by 6. So 360 tiles. With that size, we should be able to I mean, ideally we make use of the Y space of the texture a little bit more so that it doesn't consume a huge amount of horizontal space. But yeah, that would be too many. We arbitrarily decide what the limit of the number of tiles per texture. Now, there might be multiple atlases set up for each different layer of the map. So I might say there's a tree, and on the world, like in the entity space, there is a tree that the player can't walk through. A colliding texture map, essentially. But that one would have its own, because those are going to be variable in size and fiddly. Like, they're placed in a different fashion. I could just make them entities straight up because they're going to be rarer. For the most part, I just want the world to largely be an open square or a open just long rectangle, you know, wherever possible. Objects that get destroyed don't count. Those can just be entities that you pop. Okay. So we create the empty tile. We create the empty image that has a format. I think we can just use that image format there. Because we're just saying get the image format of the first one. We can just declare that's what its image format is. Then we're going to go in, and for each one of these, we create a rectangle space, or we create a rectangle that is a number of pixels equivalent to, in this case, how big a particular tile set is. And we're going to transplant from the image that we've got, a space of that rectangle, which is the whole image. And we're going to place that in the corresponding spot inside of the new texture. So we're going to have a limit to the number of tiles that you can have, which is... quickly do some math. Okay. We can have 256 by 256 tiles. Like actual tiles, not pixels, within a 4096 texture. 4096 is plenty. 256 by 256 is a lot of tiles, and it should be plenty. That limiter is also a good thing to inform how many the dimensions of my tile set, because I want to maximize the number of tile sets that I can cram into that texture. Okay. There is a lot of hackery going on in this particular tile renderer at the moment. It's not the end product. Yes, I too feel ashamed to look at an if statement of this nature. It's kind of going to have to be that way, but I will try to condense that as much as possible. So we... Oh, it's in world map. World map. So we create our atlas image, which is an image in this file. And we create a texture 2D from it. Okay. So we're going to pass in a list of texture wrappers. That's going to get us our set of textures. We don't really care about the tile width. I might set up a tile set class to cover this. Because these textures don't really have the same concept to them. So frame width and height, yes, they're 16 by 16, but this assumes a particular size for them. If it varies at all, it can't load them properly. If we want a fixed element, those are going to be special things that get plonked down on the map somewhere. So, you know, like a signpost on the road is not a tile. It is an object that I place there. That's how we're going to look at it for now. Okay, so I get a bunch of textures. So we have a list of textures. This tells us how many textures there are. We're going to need a constant for this. This can be a constant. It's not actually 0. Okay, so currently it is 6 tiles wide. And we can have 256. So the maximum tile sets that we can have is 62. No, 42. The magic number. This will be a different number once I actually get a tile atlas in place. Let me... No. Image. Boop. Okay. So this is a tile set. We can see here is the square, here is a column, here is a row, here is a lone one. Here is a vertical bar that has, this one is, it has one above, it has one below and one right, but not one down and right, and not one to the left or up and left. This kind of thing is a tile set. Ultimately, we will define all of the ones that we're going to incorporate in that and say they are all this big. If you have a tile set, this is a ground tile set. Put it on the floor, it represents a road, it represents some grass, that kind of thing. We're probably going to plonk shaders over top of these with other elements to say, this is what a grass tile actually looks like, kind of stuff. This is what water looks like because it moves a little bit or there's some reflection on it. But that's shader territory. We're not getting into that beforehand. So yeah, for the time being, though, our tile sets are test tiles. This is our tile set, 6x6. We made a couple of them so that we can demonstrate different colors, that kind of thing. So okay. So how many tile sets can we have? It's going into a square. We say 42 in a square on a side. Is that right? That's not right. It can't be right. I guess it's right. 42 times 6. Yeah. It's 252, which fits into the tiles per side. Yeah. Math is mathing. Okay, so we get the textures, and we are going to first look at the count in it. So textures.count modulus. That's not right. It's divided by. Okay, so this will get us a truncated set. +1. So we're going to take, so let's say we have 10 textures. We divide it by 42. We get 0. That means it's 1 row. We need a special case for 1 row. Because if there's only 1 row, we don't need to make the texture wider than it needs to be. But for the time being, this should be columns. It's columns on the last row. So this is going to get us our height, essentially. Is equal to rows times tile size. Okay, so number of rows, we're going to move that around for logical flow, times the number of tiles per row, per tile set in height, times the size of a tile to get us the pixels in our atlas here. For the time being, we're just going to assume that we spread a row out entirely. So the width is always going to be 42 times 6 times 16. This is a constant currently. It's not going to be a constant forever. Again, we'll calculate it like atlas height. I'm sorry. This is the width of a full row. But if it's just 1 row, width is different. It's truncated to maximize or minimize our texture size. So for each of these, now we're going to create an image. This is same song and dance that we're doing largely. So we're going to create an image object. Let's just nab this whole mess. This width, this height, and this will just be image format RGB AF. This might not work. We might need to get this from a texture. The trick is that this has to be consistent. Okay, so this gets us the basis for it. Now we're going to get our base rectangle. This is where we're pulling from it. This is the entire size of a tile set. And then we're going to place that in at a particular point. So this is going to be a row column kind of thing. Hey there, Henry. Welcome. We are mathing. Okay. Tile set texture size is what? It is a vector 2i. Static. Width times tile size. Times what now? Yeah. Oh, tile size. Womp womp. Don't feel like you have to talk about the code, folks, or talk about game dev in particular. If you have any questions or just want to chat about something else, feel free. I am typing largely. I can get kind of locked in on the code, but that doesn't mean that I can't chat once I notice. In that same vein, forgive me if I miss a statement. Okay, so where it's positioned and how big it is. So this is our super texture here. This is how much we're going to copy into it. Then we stuff it into the texture here. And tile texture size is our this is our sub value here. Hey there, D-Star. Welcome. we're working on our tileset atlas generation code. And current texture is equal to 0. So column, row. Init. Here, plus. It's not actually how I want it to be. Turn-based system? For what kind of thing, turn-based system? What sort of game are you implementing there, D-Star? Column is less than X cents per side. Top-down RPG with like your Dragon Quest, Final Fantasy type turn-based system kind of thing. Do. Row. Texture. We're going to loop through all of the textures that we have. Textures.count. So for each of these, we bail out if the current texture we're working with, if we run out of textures to work with, I should say. So at the bottom of the loop here, of the nested loop, we do that. Ah, okay. So you might have like a little splash animation of the battle happening or the attack happening kind of thing. The act the unit is taking, but not like a whole separate encapsulated combat. So like a tactics game. I mean, each game has its own ecosystem, you know, how you set it up. The whole flow of gameplay for a tactics game is fundamentally different than a platformer, usually. Could you make a platformer like that? Yes. I can't remember what it's called now, It was a concept that I always said would be neat if somebody did it, but there is effectively a turn-based fighting game where the actions take place in time slices, tiny little time slices, and each player is entering them trying to anticipate what kind of micro motions the other person is making, and then you can play it out at full speed, and it can look bonkers. Okay, so we have this, where we're going to iterate over all of the textures. And that's where we're going to do this blit in here. Okay. Current texture. Texture.getImage. So this is our source. This is where we're putting it. We're putting it into our Atlas image. And we're going to get our column and our row. And then our tile set size, X and Y. So we're copying into it. We're creating a master texture here. Oh, I had it slightly lower. We go through, and then we are going to create a texture. So we're going to do image texture create from. Okay. So this, given a list of texture wrapper objects, will spit out a super texture. For the time being, when we launch this, that's what we're going to do. We're going to get a series of textures, including this one, and we are going to spit it out as a super texture. I believe we're saving this somewhere. Did I still actually do that? I think we might have stopped saving it. Do I have... There. Get rid of it. I believe there's a way to write it out. I know there's a way to write it out, but for the time being. Okay, so this creates a tile set for the texture wrapper. The tile set is the thing that will contain everything. So this is for every texture that we're loading, the terrain set needs to be added. So we go in and we add it. We create the set, we set the terrain mode, and then we set into the terrain set a terrain. So we're going to do add terrain set, set terrain set mode, and then for each one of them, we are going to add a terrain. They will have the same layout for the tile, the same this for each one of them, the tile data. But we'll be creating the tile data once we have the atlas created. So when we're loading a tile set, all we need to know is we need the atlas texture, and we need to know the number of them that there are, because that will inform us where we're jumping to in the atlas when we're creating it. So we create a tile set source, we set its region size. And then we're going to hop along the atlas coordinates and get those. So the atlas coordinates are going to be offset by which one we're dealing with. And this is in tiles. So the region size and the there's another one that we have to set. Oh, okay. In the tile size and in the region size. So we're setting that here. So in texture region size. And when we... There's another spot where we use how big... Yeah, tile set tile size. They're the same thing. Size in pixels for all tile shapes. Just need to... I'm keeping this around because of this setup here. For now, we are going to chop out any that are empty. Just to condense this mess down. This nightmare logic. There. It's still awful, but... There. Now we don't have to scroll up or down as much. So we load that. For each one of them, we're going to add a terrain. And we're going to add the tile set source, which we are going to create as an intermediate. And then the tile map layer can have that tile map set. So when we're creating, here's our atlas. So tile set is equal to new tile set right there. We're going to take all of this. So. And our tile size. Need a vector 2i. So here we need to get, we're going to have a texture 2D. We don't actually want the texture. We want an atlas source. So we have tile set, atlas source. Texture is equal to this. And hello, Ember. Ember has come over to sit with me, or at least get attention. She hasn't decided if she wants to sit on my shoulder yet. She is deciding. And as she's deciding, she's standing over the mouse and blocking my use of it. What's the matter, huh? Hey there, Lunar. Did I add the Jackhammer Pogo platformer minigame yet? Not yet. Not yet. Or if. No, it's probably not that. I guess it could be. Have just the one there. Hello, Ember. Oh, no. Or if there's a way to get it off Wi-Fi, but that would be a stretch. Anyhow. We'll figure out why the model's hitching eventually. Yeah? Ember is chirping at me. Her head is leaning off the table in order to get scratches. I'm not going to reach over further for you, baby. She likes the texture of canvas. She'll roll around on that. I got a canvas drop cloth specifically for this reason. Cats like to lay on different textures. I've tried a few different things to see what they like. Have you made up your mind? Huh? Come here. Come on. Okay. Okay, then atlas source dot texture region size is equal to not the case. New vector 2i. Same thing. Oof. Ma'am. Hey. Okay, so this gives us a image that is an atlas source that we now have a way of saying which tile on it. Because it knows these are little 16 by 16 regions on the atlas source. And this is for, I believe, when it's rendering it, it's going to get that. So this is a atlas source that it's getting in. And not count of tile sets. We're going to say count of terrains. Is equal to 0, I is less than terrains, I plus plus. It at I. Come on now. Come on now. She is on the headrest, rolled over between the back of my head and the actual headrest, demanding all of the attention. So both arms up behind my head in order to give her back scratches as she toasts me. Yes. All right. So once we have the tile atlas, we can say how many terrains are going to be in it. That. Okay, so we're also going to want to add cells to this. So this is our create tile sequence here. And this is the messiest part. I have 6 cats, Yopi. There's 3 on camera currently. Let's see. Left to right, top to bottom, we have Sherbet and Sammy, and then Mason. Sherbet and Mason are kind of laying together. Then, I think up in the tree here, we should have Sky and Molly still. Yep. Sky in the back, Molly in the front, and then the aforementioned Ember is currently on my chair rest here. She's being very squirmy. Maybe... try that. Maybe it's losing track? Maybe. Nope. Nope. Still hitching. But why? Why? That and that. That. Performance-wise, we're not having a problem. Okay, it's VTube Studios misbehaving. Something going wrong, and it's new. Okay. So now we need to create the tiles on the atlas coordinates, and we are going to set it up such that we're going to create the tiles for a terrain. And that is part of a tile set source. Oh, okay. No, that is part of the atlas. Yes, I acknowledge that, yes. When we create the atlas, each time we add one, that's an opportunity for us to add it in, which means we know which ones they are, but we're already doing this part, so we might as well. No, it's not until here that we know that. It would be rows, columns, and count. So it's still this kind of logic, but we also just care. We're going to do this iteration again. But we can pass in rows. We can pass in a lot of this information, or we could just do this in an interior loop. We have to create the atlas texture here in order to create the tiles. But we can just do this loop again. Like, we have the information already. Is it necessarily pretty? No, but this way we don't have to recalculate a lot of this stuff. I mean, we don't really have to, and it will encapsulate it. Let's encapsulate it. Okay, terrain tiles, and we're going to say have rows, rows is all we need for that. If we pass in rows and we pass in terrain, So this is going to have a tile atlas as well. With this one, we're going to have the offset built into it. It's not atlas width, actually. When we're creating the terrains, which is going to be an iteration of... So we have created this thing. We have our atlas source. This now knows the tiles that we have. So the max tile width and tile height. So rows times our sets per side times 6. So that's the max tiles per row. We know that offset, and then the offset is our tile set height. So if we pass in a row and a column, and that can translate it out. Yeah, we just need these two when we get a row and a column to it. So this is row, column, row, terrain. That's the second one. Okay, so we could iterate over it at this point and create the terrain tiles. So it is that same loop again, but with this. So we are going to actually have a protected void create terrains. So it is that same loop, but that in here, and we are going to change you to terrain. This is less than terrains. Is rows per side. We don't actually need this part. This is terrain is less than terrains. We're going to continue here. So the loop is slightly different. So we're saying we're going to cut the iteration off as soon as terrains is when we're out of terrains. So that's not right. We're iterating over the columns. We need to do the 4 row. This is backwards. Should be row and then column. We iterating tasks, we iterating. And column. So what we're doing in this one is we are creating a stitched series of textures. We're creating them in a grid. It can only be so wide because we only have 4096 to deal with on both sides. The maximum number of textures we can have is determined in that way. So we can have quite a few textures. We can have 42 on a side. If I ever reach a point where I need 42 squared textures for a given map, I have created a problem. For the most part, a lot of this logic is going to be excised out into a given level. Like which map it uses, it will create these accordingly. So we'll have... so there's 2 elements. I could have a tile set. I will have a tile set for the ground. Just something you walk over. It has no collision at all. There may be a secondary tile set for things like walls. It will need a lot of tiles. But if I need... If I need that many tiles, so this is 42 sets, and each set is currently 36 tiles. It will be bigger than that, so we'll get fewer of them. We're probably looking at something more like 8 by 8 or so. But that'll give us plenty of tiles, and we'll have one big atlas to deal with. So we create these, and then we are going to create our tiles off of that. We're going to create our terrains off of that. We are still going to say for... It's, again, largely the same loop. Being helpful. Right, one atlas for each biome. The same tile might appear in multiple of them. as in, level 1 and 2 might have the same grass tile set, but their tile atlas will be whatever it needs to be. So whatever order they're in is what determines it there. Row. Row. Still ring ++. Okay, so secondary loop still. So then we create our tiles. Yeah, I could. And all of the textures are likely to have a little bit of extra to them, like a shader to them. We'll have to see. Things like grass and water, I could have them be animated tiles, but that gets ugly fast. I'd rather just try to come up with something that I can superimpose over them. So, like, again, a grass texture could be something that creates the motion on it. The illusion of motion by distorting the texture in particular ways. Okay, so we know what the row is, and we know which terrain it is, and we know which column it is. So this will give us which offset in the tile atlas we're dealing with. Because we know that an atlas contains a number of tiles. So it's currently 6 by 6. So our offset for our columns is always 6. So 6 times the row and column is our tile offset. And then we grab each of those. So it'll be a sub iteration inside of that of 1 through tile width, width by height kind of thing. So nested 4s inside nested 4s inside nested 4s. We only do this during load up, and ideally I will come up with a clean way of running this and then saving it off again. To say, I am going to load this whole thing as an individual instead of loading it as a series of them. So a way to load a particular level that loads the finished product in here. That I can say, oh, it has a tile atlas already. And to have it skip the step where it creates the super texture, essentially, and just does the tile creation. But that's still, it's not the biggest gain. So this will be create terrain tiles. So tile atlas. Row, column. And our terrain. Tile atlas source, and then our atlas source. I is 0. I is less than. Not a tile set. We'll have to rename that. Okay, so now we are going to do the create tile here. Okay, so we have X and Y, and we have our atlas source. It's not at X and Y. It's going to have an addition to them to create the tile there. That and that. Oh, just set height. Okay, so we're iterating over it. We're saying for a given terrain and a row and a column. Do I need the terrain in here? Oh, yes, I need the terrain because now... okay. Okay, we're going to get to this in just a moment. I will be right back. Now, folks, if you like what you're seeing and would like to see more, remember to like, follow, subscribe, that kind of thing. It does help the channel grow. But with that said, I will be back in just a minute. And I returned. See, we are joined by Ducko. Hello, Ducko. Some have said, indeed, that the be right back screen is a little creepy. I used to have a my scene transition used to be what I called the jump scare transition. Kind of your FNAF thing leaps at you, kind of concept. But it was flaky. Okay, so we need to set our terrain data here, which is what we see in this nasty if statement, where we get the tile data for that tile, and then we set it. But that is based off of the X and Y. Entirely. Like, we could set up a list in advance and just reference that X and Y value, but that really doesn't change anything because we still need to set these. Like, this is a gross if statement, but I don't know that we can actually do it any cleaner. Like, a switch is technically less efficient than nested ifs. At least in C# on these versions, it's better to have if-elses. Since even with breaks and whatnot, there's extra song and dance that goes on with the switch, apparently. Could be wrong, but that is what my reading has informed me of. Maybe that's just a Godot thing, though. Anyhow. So we need to have something like this that covers every one of the tiles, because each tile has its own little behavior. Oof. Where do we get that? We're not using an alternative tile, so we've got that. Okay, so we have tile data. And that is called terrain peering bit. Oh. Okay. I'm kind of daisy chaining these functions because of, like, it's really the nature of the loops. I have loops and loops and loops, just by setting them up. because to create this one is largely okay. So we do our atlas source, and then we do textures count. So for every texture, we pass in the atlas source here. Then we're going to iterate, since we know that we've already created an atlas source that accounts for max rows and columns. We can just iterate based on how many textures there are. We only need to know the row and the max number as far as the size of the atlas to create the actual texture. Once we know that, we can go through and set the actual terrain tiles. Okay. So that's this little bit of ugliness here. So second here. And let's open up the A sprite. It's easier to see there. Okay. So every one of the filled in cells has its own peering bits. That is, like this one sets the bottom, bottom right, and right peering bits. And it will do that for every single one of these. The bigger the tile set, the more complex this becomes, but each one of them has a very specific layout that is unique to it. So there is no shortcut. It's each one of them is a special case. Could I come up with... I could just have a single if as long as I come up with a way to set them. Like, I could do it the other way around. That each one of these, as I'm iterating over it, it's the same thing. It's 6 one way, half a dozen the other, because I need to create the thing in the first place. I could have an iteration over a collection that I preload with the data. So I know a series of values that I'm going to set. Like, I know I'm not going to mess with the empty ones, and we can compact it as much as possible, but I'm not going to set the empty ones. How do we set this up? Often you don't set this up this way. These are the vertical and horizontal. Just put them that way to rig it up. This would normally just be a square. Anyway. What's going to be the fastest way? Because right now I'm looking at a 36 case if else, which is a mess. or a whatever case, if else, with some of them being dead. So this one has 13 dead cells. So we skip we skip all of those cases. But it's figuring out how to get the rest of them rolling. Can I just hard code a series of values in a dictionary and just iterate over them? Because those are going to be XY coordinates as well as the value to set them to. And then I just have to go over that list, but I would still need that list is a list of values. So it would be an index of vector 2's to a list of properties to set on it. I think that might be cleaner, because then I can just iterate as a list. It's the tile sets are going to be variable, Thrax. Well, I'm sorry, the configuration of them is going to be hard-coded. So this is not the final configuration of the tile set. I've got to add more tiles and such to make it complete. But the layout will be the same tile set to tile set. So for testing purposes, the red one is laid out in the exact same fashion, all of them. So it's more a matter of hard coding it in the least eye gouging way. Like, I don't want to have if all over the place. So if instead Ember, hello. Yes. Interruption by cat. Cat takes priority. Ember doesn't want to sit with me at the moment, but instead she wants to stand over the mouse and receive pets. Oh, there she goes. Not that sitting with me changes anything, because she sits over my right shoulder. You can't see Ember because she's sitting on me. But you can see the other 5. Sky and Molly are up in the tree, the upper left. And then Sherbet, Mason, and Sammy are on the bed. So Sky and Molly, upper left. Sherbet, Mason, and Sammy, left side. Cat tree and bed, respectively, top to bottom, left to right. Thank you, Thrax. It's a critical feature of the Catbot Factory, is the cat observation array. The setup of it is a bit jank, but okay. Ember. One of these times I'm going to figure out why the eye is double tapping. Whether that's just my finger twitching or There's something about the way the keyboard is set up. Yeah. There are effectively 8 security cameras positioned around on makeshift pillars. I joke that I'm getting my serial experiment lane on as far as cables draped everywhere. Ma'am. Dictionary of vector 2i to list of, what are these called? Tile set cell neighbors. How far into Hitman did I get? Trying to think what the last one that we played was. I think the last one was the hotel, which was a bit of a fiasco, but I think we did it. I think that was the last one. We have a disambiguation going on here. Yeah. I do still like Hitman. It's just we have the game, we have blueprints, and we have Hitman. I plan on getting a Hitman day in this week. It was a lot of fun. I like the flexibility in accomplishing things. I know the hotel devolved into me chucking screwdrivers at everybody that came around and spotted me chucking screwdrivers. We got a ways into it before everything went sideways. But then the security room was full of bodies, like literally there was a giant pile of bodies. And I believe on the private suite at the top there was a fountain, and that fountain became a pile of bodies because people kept going to look as why people kept getting electrocuted, despite the fact that they really thought that they had turned off the electricity. Feel very confident that list is part of Godot's collections as well. Fine. That work? Okay, that's why. We don't need that. We don't need this. This can be a list. So Godot has the list ones. No, we do need it because Godot wants it. Godot.collections. Dot array. I think we can just use a single using for that. on that in a while. Nope. Anybody remember how to do that? We'll just use a full declaration down there. Okay. How do we... Trying to do this as clean as we can get away with. Might work. Go. Instead, this is this, and we're going to say... Okay. Here's our pattern. Okay. What we can do is we can iterate over this this list, and we can get the key is the position in the texture atlas, and the value here is a list of the cell neighbor values that we need to set. So in this case, 0, 0 is going to be this set, right, bottom side. Just so. This way, instead of iterating over the entirety of the tile set, I will define what what the little tile map looks like here. So I'm gonna have to come up with the actual property names here. Because a tile set means a slightly different thing in Godot. Okay, we are going to call you something different. The terrain layout, because we're editing a terrain at this point. Just what Godot calls it. Okay, so 0, 2 is our... So that's left side. That's not right. Oh, no, that's correct. Left side. Bottom left. And bottom side. So upper right corner of a 3x3. So 0, 1 has 5 different values here. It has left side and right side. Righty side. That's bottom left and bottom right. Okay, so here's the first row. And then we have the second row. These are much more akin to this one. Load all of these in just to get them prepped. No, these are the tiles. Can I still run it? I think the original logic is here. These are the floor tiles. Like, we're rendering the floor tiles. So we're setting it up so this 2x2 can be rendered. So all of that stuff I'm putting in is what tells it this is the corner of a square. Hey there, Alistair. But the player, their position is remembered in the world, just like the bullets, just like the blobs, all of that. We're rendering that little tile there at the moment. So all of this awful song and dance here is to this is yeah, there we go. This will not be the final way that these are laid out, but this is our proof of concept at the moment. So we have the square, we have the cross, we have the ring, and we have the kind of lone one. The lone one doesn't need to be defined. It just has to be created. Oh, I'm sorry. It is defined, but it has no values in it. It is an empty list. Okay, this is left middle. Bottom side. There's a top, bottom, and right, and then the bottom right and the upper top right corner. So top, bottom, right, top, that's top right. So this one has the top, the bottom, the right, the top right, and the bottom right. The one you can see right now is Ember. That camera is actually zoomed way in. Ember is very small. She is my second oldest cat. My oldest cat is the biggest one, or at least tied for the biggest. But by far, she is the smallest of all of them, or she is noticeably the smallest of all of them. She's very cuddly. Middle square. So this is going to be a centered one. Up. Up. So that's all of them in the center. It's the right, so top, bottom, left, and top left and bottom left. So we take these. He is second oldest. And like I said, smallest. She's a diluted calico. So that pale orange, gray stripy with white underbelly and socks. She likes to sit on my shoulder. She's also very chatty. Lower left, lower middle, lower right. So the lower left has its right side, has its top side, and its top right corner. And our left middle has its left and right, its top side, and its top right, top left. I tell you, plenty of people are very interested in the kitties. Okay, and the lower right has left has right, left and top. Okay. This is all the definition of this square here. Well, thank you, Thrax. I appreciate the compliment. Now that I think about it, I do recall there being an update to VTube Studio that they listed an error fix recent crashes. Well, it's not crashing on that. Annoying. Sorry, that has been bothering me for multiple streams now. Okay, so here's our square. Our set peering bits now. Okay, so for each key value pair to I to list of it's called tile set cell neighbor. In underscore error in underscore terrain layout. Tess has joined us over on the Twitch side. Rats are very cute. Each. Oh, you cell neighbor. Cell neighbor. In where dot value. Tile day. We don't need X and Y now. Isn't that great? this is different still. This is different still. No. It's peering bits is still X and Y. It's not for each tile pair. It's we can do a vector 2i here. So this is a list this. Grain layout position. Right. There. So I have the tile data for that. I can get the position for it here. We're going to do this. Okay. So, given some tile data in a position, if there is information for that one, then we are going to set it. We are going to want to have some extra information here. It's not row and column. Refactoring tiles here. Now this is iterating over each of the tiles in our tile set, but we don't need to do it that way anymore. We can do a for each, because we don't care about all of them. There are several empty ones here, and actually creating a tile for them is a bit of a problem. So this is a key value pair, and that is a vector2i to a list of tile set dot cell neighbor. Pair in terrain layout. So our coordinates are not x, y. Our coordinates are the key value pair. Equal to pair.key atlas coordinates x, atlas coordinates y, and we're going to plus equals I x with 8. Now we have our atlas coordinates. These are the tiles that we care about. And now we have a vector 2i for our x and y in our peering bits, which is a position. So we can pass that in as our pair.key. Man, since we have the key value pair here, we can just have our list here. Because previously we had to check, but if we're iterating over it, we know. So we have our pair in the information here. We have this. So we're going to get the coordinates in the atlas, which are here, but our tile layout one is still in the pair.value. Right there. And we don't need to check that. We need the X and the Y to offset it, because this is the position in the tile set. But, okay, we don't need to do this mess anymore. Okay, we cleaned it up again. So we have a series of terrains here. We pass in a tile atlas. When we create a map atlas here, we're iterating over each of them, and then we create the terrains in the atlas. When we're creating the terrains, we're going to iterate over rows and columns to get which part of the texture we're dealing with. And we create the terrain tiles for it. As part of creating the terrain tiles, down here, we're going to iterate over each of the pairs that we care about, which is this mess here. And this will get uglier for us to complete what a terrain set actually looks like. So we only have 9 values right now. There's going to be more than 9 values. Noticeably more than 9 values. But for the time being, we just have the we just have the 3x3, which will give us again, it will give us a 3x3, but it will also give us a 2x2. Okay, so we load it in. So we need to call the atlas here. So we create our source. Is equal to create map atlas, which is a new list texture wrapper, which contains this little guy here. We remove that. Create the map. Create a grape. Okay. Tile set is equal to load tile set. Get around to the names here. At the source, comma, and we textures here, and we can put textures.count here. And then we load that. Okay. So this is us setting up the cells. We are going to We're going to do this a couple of times, but first we are going to verify this here. Missing here. Where we're changing it. How do we set this now? What we really want to do is say which terrain we're setting it to. And that can just be 0, 0. The upper left corner of the tile set should always be the right thing. We are going to have a protected void set tile and terrain. UI position terrain. That's the cell coordinates. And then we're setting it to the upper left, but that's not the upper left only. So we're going to take this. For the time being, we're just going to set each individual cell. And then we're going to call the set all of the cells behavior. I want to be careful about setting the cells, like doing the whole update these pass iteratively. Like, I don't want to call set cell terrain connect multiple. I don't want to have this called for each cell, because if you have it called for each cell, it can update every cell around it. So each time, if we call it each time, we are going to potentially do 9 operations instead of just the 1. If I set all of them and then update all of them in a batch, then each one only has to be updated once, because it will have all of its surrounding terrains already known. Okay. So when we set the tile, we're doing this. But the this is the atlas position. And atlas position is terrain divided by, this is max sets per side, and this is okay, that gets us the row. And then the column should be modulo. Yeah. Okay, so which row we're on is divided by, and which column we're on is mod there. And we're going to multiply this by this is tile set width. So this is our offset. So if we have, since 42 is our limit and we have 5 terrains, this is terrain 5. So we're going to divide it. That's going to get us row 0. Let's get that in there. So this is row 0 then. So we will not have a height adjustment. Since it's 5 now, we're going to get 5 out of this modulo operator. And so we're going to offset it by 5 tile sets to get to it. So this is what we are setting on the tile set, is this position. The source identifier is always 0. There is 1 tile set. And then where in the atlas? It is always the upper left corner of it. So this is going to be a for each. Vector 2i position in cells. All set tile. I'm going to do position 0. But we're also going to do this Okay, so the offset, we're going to push them off to the right to create different terrain sets using this. So this is going to be, we have our square, and then down from that, we are going to have a big square, essentially. So we're going to go down. Should go down 2. I'm going to go down 3. So our y coordinate is going to increase by 3. It's 2. 2. Another. Okay, so then our offset for them, we're starting at 0. We need to go to the right 4. So our offset is 4. Plus offset. It's 1, and then it's 2, 2. We are going to create a separate set, or we're going to expand this array. We'll make a second one. For each this one again. Oh, no, we can. As convoluted as all get out. Don't worry about it. Tile set already had its source set when we created the tile set. Yep. Then we are going to have cells to connect. Dot add position. Offset and plus offset times 2. And then we're going to use cells to connect here. Nope. Okay. Initial pass. Initial pass here. Ugly, but we don't have to do this frequently. This only happens. We're only going to do this when we initially load the map. So set a 0. The actual terrain is the one we want. Oh, 1 and 2, and this is a that. That one is ugly. All right. Very ugly. And it didn't work. So Okay. First thing I want to figure out is, can I write... Am I getting any of this created? We have been just flying along here, so... Hello, Okaneki. Been a bit. Welcome. Atlas height is 96. Six. Yeah, okay. And the width is 4,032. Okay. The Atlas image exists. Tile set size is 0, 0. Doesn't seem right. Hey there, gotcha. Welcome. It's a static value, so it should exist. But it's 0, 0. Okay, so that's going to error out. Don't worry, I'm doing a lot of the coding, but it's largely stream of consciousness. If you want to talk about something else, feel free. Or if you just have general questions or anything like that. Can I... Like, this isn't being loaded. Maybe... acted static. Dark Basic. Huh. I've never heard of Dark Basic. The first programming language I ever interacted with was Basic. Good old clunky DOS editor. Why? Uh, so in the Game Maker class, what kind of thing did you come up with, Gotcha? What kind of stuff did you make? Once again, let's run it to here. How is that resolving to 0? This is a static value. We are instantiating it at compile time. Like, this should be its actual value. This vector 2 that is created is the right size, 96 by 96. I haven't used it myself, but I've heard Game Maker is really good at like non-action oriented 2D games. The more like movement and collision, I think the further you drift away from Game Maker, but I suspect it's still capable of the simpler ones. Okay, these static ones are not being instantiated. Look up something real quick. Like, oh, method, of course. Nope, still evaluates to nothing. Why is that? Why does this not work? Pair of integers, and we load the integers. The constants are there. Oh. Set their access level, and I have seen that cause problems before. Let's see if that was the case. Might be an issue. Hey there, Void. Hello. Nope. Did we at least get further? I am streaming on Twitch as well, Void. How is that still 0-0? Wait a minute. No, that's not the error. As soon as we referenced a later part of it. We have a duplicate in our list somewhere. So 0-0. Yeah, I multi-stream, well, I mean, for visibility, but also so that folks can watch on whichever platform they prefer. 2, 1, 0. Oh, this is also the wrong order. Middle. Two, 0 is the upper right. Left middle is 0, 1. We're making a Vampire Survivors game. Currently, I'm working on the rendering of the the ground. Two, 1. Zero, 2. One, 2. It can be interesting. I mean, a lot of the decisions I made about the structure of this is, like, what I was going to use was entirely, hey, let's learn this. Never used Godot before. We're using Godot. Professionally, I never used C# before, but I kind of like C#. It has patterns that I am familiar with and like. 0, 1, 2. So it looks like as soon as I referenced one of the static members, it pitched a fit. Nope. Let's try again. Yes, okay. There was somewhere a duplicate key in our collection of values there. Oof. We're going to have a whole battery of static vectors in that. Should just be structures. Lots of different ways to go about building this kind of stuff. Really don't. There are a lot of ways to go about some of these. Okay. Oh, okay. We are still not loading that. Let's iterate through the whole thing. Just walk through it and see if we have any. Actually. So running in C# gives me a complex debugger, but it will skip some of the Godot side errors. Things that Godot allows to go by. C# might crash on them. Yeah. Setting peering bits. Set terrain peering bit. Terrain set is less than 0 and terrain index. Okay. So I'm resetting the peering bit. Something is off. Oh, okay. Which terrain we're setting the peering bit to? Set peering bit. We have the terrain here. Tile data, its position in the on the atlas coordinates. This is what values to set it to, which one of those, and for which terrain. Peering bits. Now needs a terrain integer here. And we are going to say terrain. Run it again. Fewer errors, but all in the set peering bit on it. that we don't have a terrain set. A tile, but that doesn't have a source on it. Weird. Well, as long as we still have the atlas source, we can create terrains. So we're going to load a set, and we have a tile atlas. We add the terrains after. So if instead of create tiles, I don't want to have to iterate over this again for create terrain tiles. That's in rows and columns. That's in create terrains. Create terrains just needs an atlas source and tile. So if instead... No? Okay, this is the map atlas. If instead of create terrains here, we still need the number of textures, but so here's textures. We get our atlas source. We load our tile set. So everything is ready here. We are going to create the terrains here. So everything's been set up for there to be terrains. Let's run it in Godot. Create the terrain tiles. That's where we're calling into set terrain peering bits, which is in tile data. So our line 210, which is right here. Oh. We are hammering that. We'll run it over here. This guy is using Ember as a pillow at the moment. Terrain is 0. Still getting those errors. Okay, well, on the plus side, creating the terrain tiles can still go where it is more relevant to be. And that's as soon as I have an atlas source created, I can create the tiles for it. They are part of the source there. Run to our peering bits here. Not registering any errors here, but that's not too surprising. Integer only terrain 0 ever. Oh. Hey, Canicus. Welcome. We are going to say map background. Background and map background. They are all the same texture. Start with that. I can look up what the other ones are. Doing okay. We're puzzling through some errors here. Red and blue. Okay, that didn't load. Blue. We have the imports. Before we get to here. Ah. We are live debugging. All right, textures. There are 3 of them. 2 of them are null. It's 2 of them are not arriving in the files here. Map background test tiles, red and blue. Those exist. They have unique names. This is stop that there. We're going to hop over to a different spot where we load the textures. Right here. they should be called. Well, those have texture backgrounds in them. All right. Well, it didn't air out that time. I don't know what the difference was, but there is something about how we're loading the textures up that it doesn't like. Way more errors now. Still the same problem. It's ultimately in set terrain peering bit. Okay, we are passing a terrain index, but there is no terrain set currently. But we tried changing the order. So we have to mess with this here. We pass in a terrain, which we've got here. Then we're going to set peering bits. But it feels like there's a step missing here as far as the tile data. Terrain set. Okay, let's try that. Still not right, but this was definitely missing. Only 3. Okay. we are trying to merge the image together. Okay, let's... This was something I thought might happen here. So when we merge when we stick the two of them together, when we daisy chain the textures together. Empty one. Okay, when we do this, or when the image format. Yeah. Something off of texture to get its image format. Okay, we got to start. We have a start. We're getting there. All right, what kind of errors we got this time? All right, no errors showing up. It's now in the way that we're setting the cells. So we go through and we're going to call set cell a whole bunch of times. Now, one thing that this could imply, because we're only seeing these two, they have the right format. Need 4 to 5. So what this should be is a rectangle, a 2x2 over a 3x3, and there should be multiple of them set up. But we're not getting that. Set the bits. Our tile data for it. Set its terrain set. Yeah, there should be multiple of them here, but only the first two are showing up. So are we getting some sort of problem here? Zero, one. I'm gonna set tile. Zero, one, and we're not offsetting. So we're going to get our atlas position X and Y, which should still come through as 0, 0. Never actually setting the correct cell. No, this isn't right. Okay, so this is position. And this is the atlas coordinates. But atlas coordinates are entirely dependent on position. I'm sorry, terrain. Okay, closer. But this could also entirely be, yeah, we could have entered them wrong. Because this is left middle. This should be the bottom corner. So our coordinates are wrong. So our neighbor configuration is wrong. But our general principle is functional. Let's see if on the Godot side we have any errors. If we've got any errors. We don't. Okay. Now, it's entirely possible that when we're setting them, it's being skewed. But I still think we're okay in that regard. let's look at our combinations. Our set adjacency bits here. So left middle is configured to have top and bottom, top, bottom, and right, top right, and bottom right. For that to fire that way, though, okay, it's possible that our offsets in the atlas are wrong, and that the textures as we loaded them in seem to be correct. So when we're creating the tile, which row and which column. DF, I'm using Godot 4.4 currently. Row and then column. Row and then column. Should be assumed that the row is the Y. I'm trying to figure out. So we're creating the tile set auto drawing in it. So we're trying to create. We're trying to make sure that the logic will create a 2x2 into 3x3, and they should look as if this is the 3x3 and the 2x2 is just the corners. But we can see that it's malformed. It looks like we're setting the parameters properly. We only have these tiles being created, which means and we only ever need to set using the 0, 0 tile. So when we're setting a cell, we should be okay there, but maybe we have some overlap in our logic here. Okay, so the bottom right one, the lower right square. No worries, DF, no worries. A great deal of this logic only lives in my head. As far as the creation here. So 2 and 2. Isn't that getting set? No. 1, 0, 0, 1, and 1, 1. Down 1 and 3 rows of 3. So we're setting the right tile. And then we set tile position and the adjusted positions to each of their corresponding terrain values. And we know that they're trying to put it in the right spots. So if we go in here, the first 4 should be those 4 that I just mentioned. The 0, 1, 0, 0, 1, 1, 0, 1, 1. So the first one is 0, 0, then 1, 0, then 0, 1, then 1, 1. So our atlas position should still be 0, 0. Yes. And our actual position is still 1, 1. The lower right corner of the first square. The fact that it's a particular terrain we are going to try another thing as well, and that's cells. So we're going to do this. Just going to put cells here. So what we're trying at this moment is saying, okay, just update all of the first cells again to be sure. Closer. Closer. Now we have more cells than we should. And this implies this one is also set. Yeah, it's more working, dear. Still not working, but better. This only fires once. Moving it over by 4. Each time. Offset times 2. See any duplicates here. Cut out all of this, and we're just going to do the first one. No other changes on it. Better. We have a 3x3. The layout logic still is wrong. There's something about the way that we've got it laid out that the side ones are registering as the corner ones as well. We are making a Vampire Survivors style game, DF. So, here, you got the little guy in the center. You can move around. You emit projectiles. Over the course of the game, you'll get access to different weapons and different power-ups. you socket the power-ups in different spots on the weapon in order to create different behaviors. So these emit out from center. They fire in a burst of 3, then split into 3 twice. So 27 of them per second are being emitted. And after 3 seconds, they'll start to spiral around. And now, after 3 seconds, they start to spiral around and emit explosions. So we've created this kind of wall around us as a result of this combination. But we can also say, all right, they emit in a burst of 3, and after 3 seconds, they'll split into 9 more and start doing that. So now you can see that there's a different pattern forming. They kind of burst into these little clusters. Let's remove the explosions so it's a little more evident. It'll take the exploding ones a while to vanish. But you can see these little clusters form periodically. And that's that 3-second mark. If we reduce it down to just 1 at a time and that they split into 3. I'll have to adjust the split. I can see that it is not carrying the Z value where they are in the air when it splits, which isn't the end of the world ultimately. That may actually be okay. Because it would create weird behavior otherwise. The ball that was in the air would start bouncing. It would surge into the air even higher. But it's that iterative choose the order kind of behavior. By default, we're going to say false. There we go. Okay, now let's load the other ones in. We weren't ignoring tiles that were empty, so it wasn't updating the edge cases properly. Okay, that's still wrong. But I suspect that it's more about how we're loading them sequentially, how we're doing these other loads, than anything else. Okay, so we're only going to do the first one. Oh, there's another change I need to make. False. If this one loads correctly, then we'll get the other ones in there too. No, that's extra wrong. So we want to batch update them is the thing. When we are setting the tiles, zero and zero, and we set this to 0. All of them are terrain set 0 and that. We are creating a new array with just that position in it to say update only that one. But that doesn't work. It looks like it expects us to do the batch all at once. So if I do this, they're all the upper left corner. They are unconnected. If I do this, I'm going to say all of the cells that I changed, update them at once. Okay. Now we're going to add that. We're going to just set the other ones as well. Okay. So now instead of we're going to do, this is ugly. We are going to make a super cell set here. So this is the same one of these. So again, we're going to add cells to connect.add. I'm going to do this 3 times. Position plus offset, and position plus offset times 2. So now we're going to run it and say update all of them. Okay. And now we're going to do that again. We're going to be looking for ways to do this efficiently. But first, so that's 1 and 2. We're going to do this in 3 passes. This is kind of ugly. Okay, now we have overridden each of them. So we're going to do, instead, we're going to do it as 3 of them. We have cells, cells 2, and cells 3. We don't need the first value, but we need cells 2 and cells 3. what this tells us is that we need to set the tiles in a sweep. In order to update them properly, it is setting this set of tiles and then updating the batch of it. They get painted out, they get updated. They get painted out, they get updated. Now, we might be able to get away with this one by one in some other fashion, but it'd be a mess. So creating the map tiles is in a pass for every terrain type that exists inside of it. I don't really like that. So our offset is actually going to be 3 now. And I want to verify that this still works. Yep. Okay. So how do we make this better? So what I want to have to be able to do is avoid this. Is these extra passes. Now, I could do cells as a dictionary of them. So that whenever I set one to a particular type, I record that position in the cells. But what I would really like is to be able to call this only once. It requires the tile map layer's tile set to have terrain set up with all required combinations. Otherwise, it produces unexpected results. We have the combinations that we need for this currently. Not all of the necessary permutations. It's why when I get done with this finally, the single cell, a cell by itself, or perhaps even an error cell, will always be the 0 position. That there's a problem cell there. That way, if there isn't another rule that covers it, it shows up as the version that's a little off. But we'll see. Anyway. To do this cleanly, it needs to be 2 passes. Is one, we set the cells. So when we set a tile, we do the translation. We set the cell to that value. Then we could set up that a particular tile layer in its entirety is updated. And we do that X times for each terrain that we have set. Again, ugly, but then we don't have to remember how we set it. But whenever I'm setting tiles, I could record all of them that I have set. And rig that up accordingly. Which is not pretty, but we might be able to get away with that. So for a given, we're going to be abstracting this out into more levels. but this interaction will be in a tile chunk. And we will tell a tile chunk, these are the tiles that are in you. We'll create the atlas and all of that at a higher level, such that the tile map layer just needs to have the tile set to it. So this is when we are loading the tile set, that's one thing. So we get it set up, we get the atlas, we save that tile set off, we have multiple tile map layers that represent individual chunks of the world map. Those chunks could then be set up to say, this is the area that I render. So it's always 0 through something, because their positioning is 0 based. That is, wherever the tile map layer is, the first tile, the 0, 0 tile, is down and right from that position. Which means when I'm configuring it, its known space of tiles is absolute. When it is being created, when we give it its tiles that it will have in it, the expectation is largely those will be constant. So it would know all of its tiles and which ones contain what once it's loaded. It's loaded, it's done. If it needs to change, it redoes that process. But only for the terrains that it needs to. So whenever a terrain is changed, we update the corresponding ones, and then we do the pass on both of the changed terrains again. It's weird that we can't do them individually. That we have to do this big batch call instead of the individual calls. So like that we can't for, let's say for the first ones, for the initial gray ones, we can't do new this with position. To pass in position to make it the same. There's no copy constructor. So it's weird that we can't do that, where we update individually. For the purposes of map loading, that's not really any less efficient. But it's weird that it breaks down entirely during that process. That this doesn't work at all. So we can say that subcells, and we'll pass in subcells here. So we're not doing a new one immediately. This should be identical logic. Same issue. Why does it have to be in one big batch? Weird. This might just be a Godot idiosyncrasy here. Like, that's how it works, you know? So whenever we update a cell, we are changing the tiles. What happens if we do this again after we have done it, and we're going to do new that, this, and that, and new vector 2, 0, 0. We're going to single target update just the upper left one. Okay, that's fine. Okay, so let's go over to 3. We're going to update that one. Okay, doesn't hurt anything to re-update it. It's just that we need to do a full pass update of it. So let's go all the way out. And we're going to expand this all the way out to should be 0 through 5 to get it correctly here. I is equal to 0, I is less than 6. I plus plus. Then largely the same thing for j. Because the y coordinate doesn't change. The x coordinate is further along. Cells dot add new vector 2 I j. Okay, so we're adding the whole batch in here. Oh, this won't work. So definitely messes with it here. Interesting. But the terrain for the middle ones... Oh, okay, no, it's just totally skewed. We are going to change it from being cells here. you, and we're going to call you block. That. Get rid of that. Get rid of... Oh, no, we're going to leave you there. So we're still setting them in the same fashion. But then we're going to use block here, where we're updating the whole thing in waves. Nope. Block. Not quite. The 3s, and then we add offset. Zero through 5. That's 0 through 5. Okay, we'll only update the 1. Okay, bumps blue all the way over to the right and doesn't update it properly. And the gray one consumes the entirety of the space here. Just do this. I don't get how it's getting this as gray. This is... So it would be 2 by here, 1, 2, 3. So the whole set cells terrain connect is extending past the places that we've set for this. Because what it looks like is that you can't set ones that are extra to it. So we can't do the entire pass. So we're going to do cells.add. Do 3, 5. So it's a little to the right of the bottom one. This one should not be formed correctly. That added another there. The fact that top middle can do that, but also the fact that the adjacent one did that. Okay, now we're going to say true. Wait a minute. What you doing? I've been doing this the hard way. All signs point to yes, that I've been doing this wrong. Oh, wait. We're not doing any of the subsequent ones. That, and we're going to say terrain set, terrain. Hey there, Keys. Well, thank you. Glad you enjoy it. Okay, this isn't quite right yet, because we want to set them as a batch. We're going to say true here, just to be sure. I think we want to set them as a batch. Okay. Because if I just set them one at a time... Oh. Okay, that just didn't work at all. Let's do false. Don't ignore empties. Let's run that in Godot and see what it says we might be doing wrong. I feel like that's an error state. We might still have to do it as a batch. Oh, it's not an error state. Okay. Because what I might need to do is pass in a array that is the whole block. Parse that into pieces for each type. So if I pass in a block that has, terrain 0, 6, and 7, then it will create arrays for 0, 6, and 7 and set them accordingly. Okay, let's do that. Let's get this updated. List of int. Atlas position is going to change repeatedly during this. Or each pass it in X, Y. Okay, so this is for each row. Nope. We need a 4, double 4. X is less than terrains dot count plus 0. This is equal to terrains X plus the row dot count plus down here. We will need to deal with that further. Okay, so dictionary of int to Tess, while you're here, do you remember what the DF? Yes, that cat is Molly. Let's see. We have Molly there. We can definitely see Sky as well. Sky on the side, Sammy on the bed, Ember on the shelf. The brothers are missing. Sherbet and Mason are missing. Okay, so Tess, I want to specify that when I say array, I mean the Godot one. So I want to specify that array is actually this grotesquely long specified one, that one. Right here. So is it using array is equal? Oh, okay. Thank you. Yep, I think I had 7 cats at peak. And then 3 of them died from a sickness in quick succession. Well, Tom from effectively organ failure, from like kidney failure, and the other two from it's a particular type of virus that pretty much all cats have, but under particular circumstances they can contract a mutated version, and that got two of them. Okay, using array is equal to that. There for now, so I can to properly define. To it is. You have to. It's the C# wrapper class for the Godot array is typed. Do that. Ooh. Just specify fully. looking up some documentation. Lay it on me, Tess. What do we got to do? We are what we're working on, folks, is disambiguation. This is effectively, I have two things that two different bits of code call the same thing. So I have a list, and two different pieces of code define a list as different things. Oh. Interesting. Interesting. Ugh, gross. Will it accept this fully? Okay. Nice. Okay, good enough. It's all we're using it for, so that's fine. Okay. So we get a list of terrains, just rows and columns. No, columns and rows. That means this is Y. And this is X. Okay. So if hey there, Wiz. Welcome. We are slowly wrangling, programmatically editing Godot 4.4 tile map layers in C# code. Clearly, they did not. They didn't build it for this. They didn't. They didn't build tile map layers to cover this. Man, YouTube Studio is flaking out. Again, sorry for the model stuttering. Contains key. And the key is row X. If it does not contain the key, X and new. One of those. Because even using GD script for it would still have the same level of pain. So in Godot, it really looks like editing a tile map layer as far as what they currently have, that it's built first and foremost for editing in the GUI. So not painting it directly on the screen is a huge hassle. But once I get all of this done, it becomes much, much easier. Because then I'll be able to load this stuff from file, and I can come up with an editor that will work for it. So we add that. So that is... a vector UI array cells cells is equal to brainless X. Yeah. There are elements that I do in the Godot side because they're necessary there. It's this being burdensome. I don't know why they haven't got the code side interaction with it cleaner. It's hard to find the documentation, and it is a very specific way of doing it. Cells.add new vector 2I X comma Y. Okay, what this is doing, we're making a Vampire Survivors style game, and what we're doing for this is how we render the ground. We've already got the player being rendered and moving around. They can interact with enemies. We've got the enemies spawning. They can interact with the player and the player bullets. And the player bullets can be spawned, and they have the basics of the functionality that we're working for. I can show you in just a moment. Okay. So then we have our Atlas position. This is going to be for each. This is going to be a 2 cells in this is terrainless. So this is a key value pair. And this is int 2. This is pair. Cells is equal to... Oh, we can just do pair key and value. All right. For each of these... we now have a terrain value and a list of locations. We don't need the atlas position. Instead, I'm just going to mix you out here. And we're going to take that up here. And we are going to say pair.value and pair.key. Okay, so this will do that in X passes. And instead of doing this part, we are going to do list of int equal to new list of int, which contains those. And we are going to do a list new list of int new. So we're going to start with 0, 0. So this is if suppose x is greater than or equal to 0. One. We would not be doing this. We could do this manually if we felt like suffering, but we're not gonna. So this will then equal 1, 1. Hey there, Gnomable. Good to see you again. Thanks for the raid. We are working on our tile map generation logic, which I would like to be easier than it is, but it is not. We're making progress. How was your stream, Gnomable? Did you accomplish anything today? Select tiles. Rain. And this will totally work first time, and it's going to be great. It didn't work. Does it air out? Let's find out. We have an error. One was not present in the dictionary. What now? I saw the banner, but I had not noticed the meme correlation there. Nomable, thank you. Can just do this. Thank you, Wiz. Thank you. For those that are unaware, we stream in 3 locations. We have 2 YouTube streams and the Twitch stream. Hey there, Lore. Okay. We add a new vector2 array. At Y. No. Terrain list needs to contain rows X. It's the terrain is the index. We add that one. Yes. Yes, Nomable. Most of the people show up on Twitch and YouTube in the widescreen format. I put those 2 in. Really obnoxious. Sorry, I keep hanging up when my model hangs up. No, it does. More people come through. Okay. Now we should get a proper value here. No, okay. We're closer. Still have an error here. Given key 1 was not present. We are in set tiles. 287. Yeah, we're setting the key of the terrain value, like which terrain type is what we're setting to it. There we go. There we go. For those that haven't seen the game, it is inevitable that I must show off what it do. So in 3 seconds, these split into 3 again and start spinning and exploding. They will, as they spin, they try to converge around the player. We're getting about 60 frames a second with a complicated movement pattern. That is more than we're targeting. We're targeting about 30 frames a second. So let's tax it further. Okay. This is, they fire in a burst of 3, and then those 3 split into 81 after 3 seconds, start spinning and exploding. So we get these little 1, 2, 3s, 1, 2, 3s. And then the game starts to slow to a crawl. So we're at 4 frames per second at about 15,000 Objects, it's still climbing. We're at about 1,800, not 15,000. I wish we could still get 15,000. The screen size, does it hurt stream performance? Not usually. Network has been a bit flaky today, so we got a bit of that. Yeah, we've got some network hitches. Let's see. How would I? We do stream in a lower resolution on the tall format. We match the experience on Twitch and YouTube. From a streaming performance perspective, from an OBS perspective, how would I put it? It's only a bandwidth cost for the two widescreen formats because they're encoded identically. So there's no extra cost on the GPU, CPU. For the tall format, there is, but it's a lower encoding, so it's not as much of a strain. Yeah. Okay, and then we can calm all of this back down. It takes about 10 seconds for the bullets to dissipate, and for the new ones to be the only ones that are visible. So you can see there's less coming out of the player at the moment. The doom cloud will dissipate shortly. There is a great deal of footwork that I've been putting into my architecture to make it so Godot can handle this. So now we're back to, yeah, it's if you get to the point where there's 1,800 things and that many projectiles, I don't mind that it goes to 3 because you have broken the game over your knee. You get to win. You get to say, I brought the game to its knees. Look how cool this was. This is a more plausible use case. To back up all of my... anyway. Yeah. Okay, so we got the tile loading in. Let's do another set here. So to make it easy on ourselves, we are going to want to take that. We're going to do them well, no. Copy. We're going to set them up vertically. And we're going to put ones here. Ten is not a thing. Okay, and then we're going to do it one more time. And we're going to have 1 and 2 and 1 and 2, 1 and 2. Yeah, let's do 2 and 1. All right, Wiz, thanks for coming through. Thanks for swinging through and watching with us. Okay, so we have set 0. We have set 1, but set 1 is broken. There's some extra flaw going on there. Let's take a look. So we should have tile sets for 1 and 2, for 0, 1, and 2. Let's see if the Godot side tells us something is wrong. If we get fresh debugger entries on the Godot side, it means that there's something that C# can't see. Yeah, the whole third set isn't coming through properly. Now, it's possible that it's because I don't have the proper setup for that. Yeah. Okay, let's just change the last row. I'm pretty sure I know why this is happening. But I'm surprised that it's coming through garbled like it is. I'm surprised that this set is happening this way. I know from an adjacency perspective they can handle it, but okay, let's do 2 and 1. And then we have a space. So we have none of them that overlap strangely or in ways that they shouldn't be able to handle at all. Oh, thank you, Wiz. Thank you for the tier 1 subscription. I appreciate it. There are emotes and what have you that are unlocked with the subscriptions. And we get the cute little pop-up. I always check to make sure it's still working. Because of the nature of my stream, I have to have a custom one. And thank you for the bits, Parakeet. Okie dokie. So one possibility is that we just haven't set up the terrain set to have the rest of the elements there. So let's explicitly create the tile for the empty one. For the solo one that has nothing in it. All of these are okay. Center square. There. Oh, and thank you for the on-screen celebrations as well, Wizzy. Thank you. Is it Wizzy or is it Wiz? Anyway. I appreciate it. It's something that I always say when people donate in this fashion, is do not feel that it is required or that I expect it in any way of you, but I appreciate it if you do. Spend only what you can afford to spend. Okay, these end in commas properly, so I can do another one that is a... Hey, I appreciate the support, even if it's just a small amount. All right, thank you again, Wiz. Okay, and this one has got to be... This is 4-4. There's nothing in it, but we're still going to create the tile for it. This creates a solo one. So what we're going to do... Go all the way down in this mess. Let's see if this changes anything. So I'm not loading anything there. Wonder if there's a way to set a default. Let's put a -1 in the middle here. This means that in the bottom chunk, nothing has adjacency with a fellow color. Okay, still not loading any of that. But we don't get any error cases. All right, well, what if they're all just 0 again? We'll make them all 2. It should be the blue ones set up now. Okay, there is something about the layout of them that doesn't play nice. Ignore empty still worked. Now let's mess with this. We're going to put a 0 right there in the middle of it. Okay, that scrapped all of them. There's a nuance here that I'm missing. There's something missing there. Not ignore empties. Still put that center one there, even though it's set to be nothing. All right. I think we've made sufficient progress today. Let me just double check a couple of things here. You know what? Let's go a little bit more. I've got some momentum. Okay, so what we're facing now is that we potentially don't have all of the permutations necessary to get this whole thing in there. So let's get the rest of the tile set together. This guy here. What I could do is have a different layout for this, but it's not going to be any cleaner. So this is the solo tile, which should be 0, 1, 2, 3, 4. Yep, should be here. This one has no neighbors set. Then if we set these, we can get more of our patterns in. So we're going to add the ring next. Mama. Just empty. Oh. That's odd. Still not properly covered. Because this one shouldn't be getting specified as 2. Why would it do that? It should be 1. $116. And it has to be at least that, so the -1 should get skipped. So we're looking to see if like 116 gets set here. And 2. Okay, that one's not being set. Like we aren't setting that one. But it's still filling it in as if it is present. We should not touch an empty cell. Oh, do I have to expressly set them? This will include -1s now. I'm gonna set that in there just to be sure. Oh, that's still a problem. But we're not setting that center one. That center one should have nothing to base that off of. It's weird. Because this is definitely a different cell. Like, this is a different value. I can put the same test up here. So we don't have to move much. We'll run it in Godot in a moment and see if there's any errors showing up there. Okay, you worked. Why did you work? I mean, it's not what I want, because the shape is wonky. It's doing a best fit. But one would think that we would actually need to do the ignore, though. Let's verify. Look at our peering bits again to be sure here. This tile is looking for this terrain in that direction. And the others by default are -1. Let's check this real quick. What are... Force them all to look at 0. That's not what it do. Okay. You can set it up so that if they're adjacent to a different terrain, that they could give you a different tile. That's how you can do things like transitional tiles. You know, if sand abuts water, it looks different than if it is adjacent to, like, dirt. It seems like it's correct. Like, we're getting the correct values set. So if I do 0 here, this should give us the solo tile. But we didn't. Solo tile is defined. It has nothing adjacent to it. Can I set the -1 bit? Side. Left. How would I do that? We've created the tile. We have tile data. We're coming in and saying that neighbors is empty. We have no neighbors to enter. So we're going to do if so we're going to say if neighbors count is 0. Then we're going to do a special one here. Up, down, left, right, left, right, left, right. Side. Bottom side. Left side. Side. Left. Hello, sky. I acknowledge you. Yes, I do. Top right corner. I'll have to make sure that we are getting corner and not side in some of these. That could skew some of them. Bottom left corner. Dodging cat here. He's giving me a look that says he's going to start causing trouble if I don't pet him, but I'm trying to get these entered here. Should have copied those, or set those before I copied it. Okay, if there are no neighbors in it listed, we are going to explicitly set all the bits to terrain -1. Still didn't work. I'll run it in Godot and see what's going on. Are there errors? Tell me if there are errors. There are no errors. Our tab, go over here, core game. Map tile render, tile map this. See nothing here. which is weird that it doesn't show us anything, but it's not a scene. Tile set is set. Edge corners and sides. 3 terrain types. Is very strange. Why would this one not come through? That's 4. Yeah. It's 4. 0 indexed. It's 4. We set it to explicitly have no peering bits. Which should mean that it operates only under this circumstance. What peering bits are there? So we know that this does nothing. This will create the tile, but it won't update the tile data to have peering bits. Do get in here. Materials. We have terrain. Why do we have a terrain of -1 on this tile? Tiles. That how we messed it up? That we weren't setting the actual terrain of the tile data? Well, that doesn't seem to have done anything. Terrain should equal 0 when we get to this one. How can it be? It's terrain set 0, but it's still terrain -1. Map tile render, when we create terrain tiles, we are currently doing that before we do add terrain to it. Let's create terrain. So we're going to, once again, take you from here. Move all the way down. So we load tile set here, where we have created the tiles. We have the atlas source. So we've added terrains. We are going to now do that. Just so. We are now creating it after we have loaded terrains into the tile set. Still not doing anything. Tile data dot terrain equals terrain. Oh, and I don't. Oh, that's another marker. Is I have to say the terrain set so that it knows if there are terrains in it. But that. Ugh. Now the terrain is set. Okay. I don't know which one that was. Okay. 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 Progress. Okay, so now we're going to put you back here. And in our load tile set, we're going to comment out you for now. Do it again. This time we're setting those values in the right order. Okay. We can still do this in the most rational place. There we go. There we go. That's what was missing. We weren't telling the tile data which terrain it was part of. Now this is still not great. The empty that it's got here, that's not quite right. Let's continue here. Ignore empty true. True is the default. There we go. There we go. These are unrecognized tile types. So they default to the one that is empty. The solo tile is the default. Okay, now we're going to set the second one with 1s to -1. Now we have the one with 2s. So we're going to go 0 and 0 and 1. And we are going to have that 2 there And we're going to put 0 and 0 and 0 and 0 and 0, 1 and 1. Now the editor, I'm going to make an editor to create that double list. Yeah. Yeah. I wonder if it's the iPhone side. That's also possible. Maybe there's an update to the VTube Studio iTunes or iPhone words. All right. Now it's a matter of getting a tile set created to fully contain all of the permutations, define the cells that go into those permutations, and make it so I can load that. So what we need to do is we define all of these. This is not the full set. This is actually only a portion of the set. This isn't defined yet. This isn't defined yet. Like in the listing. But I also need to change the layout of this to handle it properly. So again, hey there, Garrett. Welcome. We just got our tile set loader working. Gonna test something. Do. And okay, we're gonna see which part of the app it is. No, the hitching is still there. That means it's not the phone side of it leaking. Could still be. I'm annoyed. So as I describe where we are, I'm a look at a thing. That is Molly, Garrett. Okay, there's no update on that. Huh. I don't know. Molly is my youngest cat. She is the newest of the bunch. Loading. Okay. Yeah. Let's see. Maybe. Wobble. Nope. Just looking at a couple of things here. Yes. That is what we're working on, Garrett. What we have just resolved is getting the tiles loaded here. So these little guys here, these are the map tiles. let's try this actually. We're gonna see what... No, it's not that. Okay. Oh well. I don't know. Avatar keeps hitching, and I don't know what doing it. And it is much annoying. It keeps distracting me, but with reason. Okay, we'll do something off stream for that. Some further actions I want to take, but some of them will be a little trickier. Yeah, we're going to get to circumstances where we have different enemies, Garrett. But these are the testing ones. The initial level enemies will be very different than this. I just had made the blob sprite and thought it was cute. The little guy in the center is the main character sprite, though. Okay, I'm going to check a couple of things again. Yep. Ah. Here. We're going to take a short break. I will be right back, and then we'll continue. Sorry about that. We are back. A little longer than expected. Or kind of congested. Let's get the rest of these little guys in there and make sure that I've got it laid out. Actually, no, I'm going to move things around, so why bother? Okay. So let's think on this a moment. We are going to make a new layer. So we need a filled square. Which is this one here. We need a row and a column. We need a solo one. We are going to give ourselves a little bit more space here. We're just going to double it out. 92 by 192. That. Okay, and we're going to add a couple of colors here. Okay, so we need the equivalent of these. So we're going to put a little we're going to box the ones that we actually need. Need this one. That one. Nope, 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 nope. So we need these. We need the equivalent of empty corners. Okay, I think I know how to represent these. Okay, so we're going to set this up. Like that. Edit, flip vertical. Another one, edit. Rotate 90 degrees. Copy that. Put you there, put you here. Flip horizontal. Put you here. Okay. So now we're going to really emphasize these as much as we can. Actually. Okay, so we're going to make you red, 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 and you blue, blue, and blue. Which means we can... that. Oops. Line. Oops. Okay, well, that's good enough. Okay, so this is our default tile. This is the loner tile. So we're going to keep him there. Then we have a tile that is you here, and you here, and you here. Then we are going to have a tile that is like this. Okay. These tiles have nothing all around them except to the right. This one's the same except to the left. This one says only left and right. This is a row. That, paste it, edit, rotate clockwise. So now we have another row. Just so. Okay, now we're going to take you again, paste you here, here, here. That is not what that tile actually is. I'm using that as the this is everything tile. Okay, this tile is gone. This is the there is nothing around me tile. So we are just going to put a little... just so it's apparent that something is there. Okay. Then this one is like this. So right, left, and bottom right. So all the way down the sides of the squares. We cut them off like this. Just so. You know what? We can actually represent this better. That, you, and you. You, here, here, a little easier to see the joints in the structure. I would also have accepted using green instead of yellow. Okay, so here is our full block. Now, to make a donut pattern, we don't actually need the 3x3. Let's chop this guy off accordingly. This is ultimately going to be our tile set template here. So they're largely going to be like these guys. With one major difference. That's going to be that we hollow out the center of it. Take this. There. So these are little L curves. Then we also need ones that have the diagonals set up. Now, this might not be 100% necessary to get diagonals in or all of the permutations, but for the time being, we're going to roll with getting everything in. So that one, we're going to move you over here, and this is another that, and that. So if you look, this would be identical. We don't need a second one of those in that configuration. Put you here. Then there's some of the other ones. We have the plus shape. We'll figure out how to organize these so that they visually make sense. Oh, okay. I know how we can put the plus one in. We have that. These are still usable down here. We're looking for coherent blocks of space so that you can look at them and say these are all like entities, you know? They make sense together. So now we've got those. Take you and put you here. And you and put you here. And we're not going to complete those because it would cause some problems for us in a moment. Until we get the rest of this filled in. Yeah, it'll do that. It can get that way, schmuggums. This is why I'm trying to do that, so that if I have to make more tile sets, that the pattern is coherent. Okay, so this is, none of them are filled in. So I have a T-junction, I have a four-way intersection, that kind of thing. Okay, where do we put the rest of them? And what are the rest of them? Those work together, those work together. We have the corners, which gives us the four-way corner. We can have composite diagonals. So our kind of our manji and reverse manji kind of things. Which again, we have to be careful about laying out because people will get all upset. We have those straight lines. We have that one. What other ones do we really need? There are lots of permutations. ultimately, we need effectively 64 tiles, minus some for effectively duplicates. But I think we only actually need 64. Will I need every permutation? No, and a sheet doesn't need everything. You can leave empty tiles in there, but you'd need to make sure that they are undefined if you do. What we want is that it would always be able to fall back to a reasonable tile, though. So, let's see, what are some other possibilities here? How can we present them, again, to make sense? So, we can have things like that. We could just have it where we don't have these kind of diagonals as far as handling. But it's making sure we can still get these patterns in place. And get them to correspond properly. Flip horizontal. And flip vertical. Another one. If we get every permutation in place, then we don't have to worry about weird edge conditions in it. So for the time being, we're going to move you up here, take up some of that space. You over here, take up that space. It's deciding where we put overflow elements, that kind of thing. Okay. Then this one again, but what if these edges off here here, and we're going to rotate you 90 degrees. Just so. They remind me of Space Invaders. Okay. Going to further subtract here. So we don't need to remove that last one. Because that makes them into these corners here. So now we have you again. But this time we are going to remove these. Do this again. But we rotate it 90 degrees. Okay. Let's get another one here. We can do this. And we can pull that. Actually, we have to take this whole mess here. So we don't have quite all of the permutations in place yet. So we have this one removed. So all of them, the corner removed. Dang it. Didn't think about that. I do need... I'm going to get this little guy down here as a template. Any patterns with this that I am missing, but I don't think so. So we're going to peel you off to save space. This, and we're going to remove the inside here. But we don't need to, because that's identical to this set. Any combination of removing those edges is a duplicate. You... kind of like it this way. Like that. And again, we don't need to chop the middles out. That one. You. That. You. Two each, three each. or each is a solo one. Move all of the yellow here. The one that's kind of unique. Okay, we need another one of these. I'm going to remove that blue, that blue. That blue. See how many of them we've got here in a moment. Okay, take you and copy and paste that again. Now we are going to take those out. We have another center radiated one. And currently, let's see, how many do we have? Not nearly enough yet. What's another one off of this guy we don't have yet? There is this, where we're missing the diagonal blues. We have the permutations of removing the yellows here. Now we're getting into the yellows and the blues being removed in sequence here. This over here, we're just trying to pack them as tightly as possible. I feel like I'm missing something in the permutations. It should be 8 by 8. All right, let's do another layer here. We're going to take from this layer this guy. Hide that layer, move up to this layer. Okay, we are actually going to put this one... All right, these will be the iterations of removing only one. Here. That out of there. This is another pattern that we could potentially get away with. Oh, wow, yeah, we're, I mean, when it's just down to sprites, you gotta just keep going. All right, here are all the permutations of one of them removed. Now we're going to go through, and now we have, for every one of these, there will be one more off of it. Or I'm sorry, there are 7 off of each of these. Because each of these 7 can be removed as part of this. That's a starting point. Now, there will be duplicates that result from this. And that's one of the things we'll have to do. That was highlighted, and I didn't get an indication of why. Okay. Well, thank you for the message effect bits, Tass. There are some of them that are trickier to notice, so forgive me if I don't see some of them. Wait a minute. Should be active. Twitch, what are you doing? Okay, well, no, it's okay. It's fine, it's fine. $0.20 is 20 cents, man. Nope. Off of you. Right there. Okay. So here's all permutations of 1 removed. These are duplicates of that. So let's go up here. Pull you up a little bit. And here are all of the permutations of 2 removed for this one, for this column. Save ourselves some time here. Again, there will be duplicates during this process. Like right here. So top center is our basis. Is there a better way to go about this? Probably. So we can already see some of our little buddies here as far as some of our duplicates and some of the things that we made in the last pass. What we'll be doing is we'll be culling them down. We'll go through and say, okay, this one's already there, so we just get rid of you. So any of them that have top center removed, like this one, that's a duplicate already. I thought I had a tool for that, but I don't. Okay. Right. Same way, any with top right. So top left and top center are the two that I want to look for because those will duplicate. And now this one is a duplicate. So top left, right. Where are you hiding? Here. So this one's a duplicate. And then if I go top center, it would be a duplicate. Permutations, unique permutations. All right, so this one would be a duplicate. This one would be a duplicate because it is top center that we would be removing. And then this one would be a duplicate because it would be top left. If I adjust this properly, let's go. So we didn't do top left and we didn't do top center. So here's top right. This should actually be. So there's two removed here. If we take that and we run it down, do you see a pattern forming? So now we can expedite things. So we don't need to do anything on the prior one starting with top left. All of those are duplicated already from here. So with this first one, I should do bottom right and then center, then bottom left, and here. Those are the only non-duplicates of it, are the ones that start from where it is. So if we always start with top left as far as removal, we can get this decaying list here. That doesn't seem correct. I feel like I've made an error here. If this one, oh, it's because I started at the wrong spot. this one. Okay, and once again, okay, and you are like this, and then like that. Sure, I'm starting with 2 removed in each of these. Okay. And then you have a permutation, which is this one. Okay. That is every combination involving 2 removals. Oof. Now, each of these will have permutations off of it in the same way. Where for each of these values, we're going to branch off and say, okay, I'm going to remove 1 more. So now we are just going to expand our canvas. Just so. So we're going to take you over here and we're going to move you to the right one. These are all of our 2s. Take me a moment because I'm a bit OCD like this. Everything neat, everything tidy, everything where it should be. This is why I'm insufferable to play with in games like Minecraft. Welcome back, Wiz. Oh, I know that feeling. Insomnia is a real drag. We are doing permutations here. Those are like combinations. So there are, aside from the center red, there are 8 spots around the square. So accounting for each corner inside. Each of those can be present or empty. So effectively, I can flip the light on or off. The red stays. What that means is that there are 8 possible states. I'm sorry, there are 8 possible switches. Each of them has 2 states. So for each of them, it's the number of combinations is 64. Where I say, okay, for each of these slots, how many different states are there? So for this one, it's 2. Okay. And then for each of those 2, how many states are in the second one? 2 again. So 2 and 4 and 8 and 16 and 32 and 6. Okay, there's way more. My math was wrong. We have a huge number of permutations, but the trick is that there are duplicates within it. So some of these do not, some of these are always going to be copies of prior ones. So that's why we're lining them up like this. Because as we extend them down, we'll start to see that we'll see that pattern. Generally, it forms kind of a stair step, just like this one did. Could we do this differently? Yes, I should have done this differently and alternated going vertical and horizontal off of the list, but we're continuing our pattern. We're extending down from each one and creating our permutations accordingly. Should I have kept them extending off of this so I could see the process as it unfolded? Yes, I should have. Did I? No. It's too late to go back. We've come too far. All right, we are going to create the full row here, because it's faster to grab them locally than it is to move them all into position at this point. That's the idea. By looking for the duplicates, by setting it up to find those duplicates, we can avoid the ones that are... We can avoid duplication in that regard, but additionally, the rotated ones are accounted for just in the process of hunting all of them out. So, like, some of these are rotations of the others, but from a sprite perspective, we can't just rotate them. Because you'll get things like pseudo 3D, that kind of stuff. Okay, so here are all the permutations of ones that have 2 removed. So now we're going to go down and we're going to remove 1 more from each of them. And if we look, there are going to be, off of this 2, we're going to have 1, 2, 3, 4, 5, 6 variations on it. So I can take that. And that. So now I can go through here, chop, chop, no, this is not for lighting, though the coloration does show up in some things like that. This is for, well, okay, it could be for lighting if we were dealing with squares receiving light. I would probably do it at a more granular level if I was going to do it that way. This is for combinations of tiles. So if we look here, these are permutations as well. If you imagine each of these is that multicolored square, this one would have the right yellow, the bottom yellow, and the lower right blue filled in. It would not have any that touch on the left or top side. They connect to each other. And we're looking for all of those permutations so that we can create a sprite sheet that encompasses all of those, and then we can also decide any that we want to leave out. But generally, you don't want to leave any out, because you don't know if it's going to show up, and you don't want it to look silly. Okay, so for this one, the first one that I would remove, I should always remove from upper left and rotate around clockwise. That's our pattern. If I remove this one, it's a duplicate of the one right next to it. So we just skipped that one. So we skipped that one. So now we're moving around to this guy. and we rotate around from there. So you see, we're starting the stair step now. Now you'll notice this stair step is going to empty out pretty fast. This is good, because as we add more and more to remove, the likelihood of a duplicate is higher and higher. Yes. Every type of development has its own issues. Like, I've never done some elements of web development. Some parts of the stack I have not been directly involved in. I've touched on them, but my experience with them is effectively nil. Okay. So if I remove this one, I'm sorry, in the first case, I would have removed top center, but that touches on this one. The next one I would remove is upper right, but that touches on this one. So we go to here. So copy this one. Yup. Okay, and you. So if I do top center, I overlap with this one. If I do top right, I overlap with this one. If I do bottom right, I overlap with this one. Sorry, right center. So this is where I am. So I come around and I do this. If you look, the pattern is we always start, for the most part, with the first one in the upper left, as we're starting in the upper left and going around, but we're going to skip all of these down to here and say, okay, what's the next one after this? So this one was the top removed, which means we start with this piece. And then on this one, it's up there. So this is the piece that we remove. And then this is the piece that we remove. Now, the next trick is going to be making sense of the organization of these. Okay, so we have this one. If we remove this, we have the same as that upper one. So if I remove this lower right, then I have the same as the one right up here. So this is the last piece in the rotation here. So I'm going to take this piece. And then I'm going to take this piece. Okay, and there's only one variation of this one available. Should be this little bit right here. As for this one, we have this piece is one of the ones that was removed. So we get the next one, and then this one, which means we started here. We're going to grab that next one. So we remove this one. So now we have the left side of a full block. So if I look here, we don't have all of the permutations off of this one yet. Because we would have the upper right corner aspect here. Trying to think. I feel like we're missing something here. Okay. All of these are permutations off of the upper left is already removed. So there's cycles off of this one being removed. So we can see that this one stays and it ticks all the way back around. Now we've got this one. This is different. We're starting with the center, but if we get all the way back around on this clock face, we're going to hit that. So my layout is a little tricky for our permutations now. Because when I hit this one, if I go down from this, we have a match with this guy. So we need to figure out a way to organize this accordingly. And find those duplicates. So I think if we start with this one, we should be okay, because this one always has these two off of it. Let's see if we do get duplicates. There are effectively subsets here that I think I've lost track of. Now, one thing I could do is make this an algorithm and spit them out that way first. But this is kind of what we're already doing. We're going to have to get those in. So left, and here, here, left, bottom center. And then if I do this one, we now have a duplicate. So we call that one. Interesting. Interesting. Let's see how the pattern unfolds here. So if I take this one and cut the upper left, oh, okay. We have a flaw in the way I broke them back out. This one, and then it rotates all the way back around to here. So then we have this one, which is one further, and it can rotate all the way back around, but stops here because that would be a duplicate. So we have that. So how do we figure out that there's a collision in this space again. How can we do that? So again, if I do it this way, then we see that there's already a double collision with it. So if I cut this one off here, wait, this has come all the way back around and is 0. As in, this is the last of the ones with the upper left in it. There is nothing that it can turn into because there's nothing left to remove. This is a gap. So then if I take this one, so this is all permutations where the top center, it will lose the last one because that will overlap here. How is... Oh, no, I accidentally made a brush. Control B turns it into a kind of a stamp, which can be useful, but I want to be able to carefully align it and not mess anything up. Okay, so we remove you, and then you, and then you, and you, and then you. But if I remove that last one, I duplicate up here. So now, since the next thing... Oh, wait. No. The first one to remove is always the upper left. That collides over here. So we're starting one lower each iteration. So I can't remove this one in this pattern, so we're one lower. If I had left them all in place in the same way, we could have branched this further, but you can kind of see where we're going. So we can't remove this one because that would duplicate, so this is the next one we remove. Then this one. Then this one. Then this one. Yeah, top center is where we're targeting because we don't want top right because that's already covered. So we rotate all the way back around. But we don't touch it further because that top center is already consumed. We drop down. Now here as well, we couldn't remove this one or this one. This is our first, sorry, this was the first one removed. So this will be the next removed. Because I can't do this one. It would overlap up here with one of them. I can't do this because it will already have been represented. Is it? here. Like if I cut this one. If I cut this one, it's the same as the one above. So I have to cut this one next. And then this one. And then this one. So go down one. This was the one that we started with. We start here. Start with removing you, and then you. Down here, you down. And we started with this one, so the only one left to remove in this iteration is that. Now we take this one, and if we look, if I cut the upper left here, let's see if we can find it. I think we can cut the upper left on this one, but we'll have a different marker here. I suspect we're going to run into a different pattern shortly. I think I know what it's going to be. Okay. So, with this one, I can cut this. Actually, no, we have to have that around, don't we? No, okay. So I can cut that one. So now if I cut the upper right, though, that collides with this set. So this one's gone. So I can't cut the... I couldn't cut the upper right. So now I can cut that one, right? But I think I have that one right here. So I go down 2. So now we can do lower right, and then center should be okay. Let's see, do we get you anywhere else? We do. That one. Do we have you anywhere? Oh, the trickery is gone now. Looks like we only have this one as far as 3s. Is this one around anywhere? So these are 2. Okay, no, this one's gone too. Okay, it's still very similar. We should be starting... This one should be unique. Right? That's a top center. So we're looking at top center, which is this set here. Top center and left. But top center and lower right overlaps with that one. And top center and bottom here overlaps with this one. And top center and let's see, that one's left. What could we remove from this that wouldn't already have been accounted for? That's this one here. If I remove this, I collide with this set. If I remove this one, I've already collided with this set over here. Down here, again, I will have collided with... actually, I think maybe we can do that one. So I can't remove you, or you. So I should be able to remove this one. But no, that will collide here. Which is iterations off of this one. Iterations off of that one. I think we're out of those. So we have a gap. In theory, I should be able to take this one, and we're going to iterate it out, but we should be able to see some duplicates right away. Perhaps not. We have variations here that I'm not quite finding. Okay, so if I try to cut this one, I'm overlapping with this group. I'm sorry. If I cut this one, I overlap with these guys. So that one's gone. If I touch this one, I overlap with the group behind me already. If I touch the bottom right, I'm okay. Which gives me a symbol we don't have yet. So we have there, we have the top right. Should be able to touch that one, and that one. Okay. Take you. We're going to do the same thing. We're iterating down. Okay, so this was the first removal. That means that's this one. And this one. And this one. Take these. Here. Here. So this one was the first removed, so now it has to be this one. And this one. Take this, put it down here. So in this case, this was the first removed, which leaves us with this guy. And then we have a gap. There's nothing off of this one that we can remove. So then we pull this guy down, and in theory, we should be able to pull it all the way to here. Okay, so this has been a fun exercise, but I feel like I don't need to go this far. I feel like we're going too far. So, as fun as that was, I'm going to banish it, and we're going to revisit this guy. And we're going to look at this as a, what do I actually need to incorporate here? Diagonals are relevant, but I'm not too worried about them. That is, if it's only touching by a diagonal, I don't know that I actually care about it. What I would care about is if this one touches a diagonal, but that's kind of map design at work here. Where we don't want to have isolated diagonals. We can with some tile sets. but not with, it's not necessary that all of them have that. So then this is one where we essentially have okay. We have this is where the sides, both sides are not touched. This is where none of the corners are touched. So these guys are kind of similar. None of the exterior corners are set. This is one where we have additionally the corners removed. This is one where we have none of the left and right corners, interiors are there. And its sibling, the top and bottoms removed. Then we could have similar with the interiors. But again, I feel like we're getting into tricky territory. Like, I feel like this one is useful. Any of the isolated diagonal touching is useful. Let's see, this is one. How do we organize? With the 4s, we can just make one change in the corner and then rotate them. So let's get a bunch of these guys out of here. Okay, so this is the first iteration of altering 1. So we take that and we put you up here. And now we are going to change, we're going to look at it and say, okay, what if we change this piece? So that is with one piece removed. So we can see that it's going to get increasingly complex if we keep going down this road. And I don't really wanna. So we're going to limit it. This is an interior corner. So if, you know, this space is empty when I'm spreading around. So this is a valid one. This is if we're in kind of a U-bend. This one is valid. We can further exacerbate a interior corner with this. So we have this little L joint in here, and we can mirror this guy a few times. Horizontal and flip vertical. So that is digging further into our interior there. Where we have a little bit of a dip into it. I feel like these are still valid. Take this one. And we can remove G on the right click. Right click, right click, right click, right click, right click, right click. So this is further rounding off the corners here. Do we need that? Do we need this? So these are, again, this is a U-bend. This is it's on a corner. It's on like a slope here. So it has above and right. So if we look at it as like you're standing on ground, what does each of these represent, you know? So slopes upward on the ground and on the ceiling. This is a light indentation. This one is shallower slopes. If we chop 4 of them off, we're going to get rid of these diagonal onlys for now. I just don't want to deal with that if I can avoid it. But we're getting into rapidly increasing permutations again. Because these I can see, these are extensions off of the U-bend. And if I were to put something in between these, it would have to flow off of it. I feel like we've probably got it. Okay. Have to look at any of the others here, because we have the pure diagonals. What if we include this with a gap here? Again, I want to avoid these ever appearing, is the thing. But they definitely can. I feel like we've got duplicates here. Yeah. This one duplicates this one. This one duplicates that one. Going today? It's doing okay for me. Get rid of you because you're presented up here. Get rid of you because you're presented up here. You because you're here. You because you're here. You because you're here. You because you are here. You and you. Okay, we narrowed that down. This is good. This is good. We're getting there. We've already got the full sides there. So we're looking at ways we can reasonably connect to another tile. We have our raw diagonals covered there. I want to avoid any of these that we can, but it's a possibility that they appear. So we're trying to cover our bases. We can take this one and say we remove another piece of blue here. And we flip horizontal, goes over here. Flip vertical. Goes up here. Okay, and then copy and paste and flip horizontal. There. Okay. Is there any other way that we can set this up? So there's just one above me. Think we're good here. Okay. Now, how about this one? We're going to cut one more. Take that. Rotate 90 degrees. East. Rotate 90 degrees. 8 degrees. Take that, paste it, flip it horizontal. Okay. Take this again. Pull this piece out. This. We don't need to flip this one horizontally. This one we did, this one we didn't. Chopped that piece off, got us this one. We already have those corners accounted for. We take this one and we crop this piece off. Degrees. So these are still, they're not connected diagonally, is primarily what I'm looking for here. Like, we still have this core central bit. Yeah, we're gonna change the positioning on that. Just so. You can see the sizes of the corners don't quite line up. The blues do. The blues are 5x5s. So whenever the that's why that doesn't work. Blues are always in a corner. So we've got all permutations of cropping one more off of that. We can take here and we remove this one. Rotate 90 degrees. Rotate 90 degrees. There we go. Need to flip that horizontally. No. Looking to see if any of these are already accounted for, and I think we needed those, yeah. Okay, any other variations on this do we need? So take that, paste you over here. Pull that out. Rotate 90 degrees. Just like this. Those. Then we have you, where we remove this. Rotate 90 degrees. I acknowledge it's very quiet. This is not... This is grunt work. That's what we got here. Okay, what if we take... We take this one. Oof. Do I want it to be this complicated? I feel like I don't want it to be this complicated is my problem. I don't like missing diagonals like this. I feel like we can do better without that. So, executive decision, we're simplifying. So we have corners here. We have U-bends here. We have slopes, interior and exterior. This would be if there's a corner here. There's something up here, but there's nothing over here. There is something here. Because if we only allow for solid tiles, okay. It goes back. If we only allow for a tile to be entirely solid, then these blend with these. They are the concave corners as opposed to convex corners here. If I have one here, then we bridge into this, but that means we have a different pattern here. It's so complicated. It allows me maximum flexibility if I keep digging into this, is the thing. So we have further permutations there. If we take... Wait. Those... it allows us to have rounded corners. I'm kind of talking myself into this. This gives us the round off there. This gives us a protrusion. We've already got those. We have you. So if we take this one, oh no, we've got it there. If we take this one, truncate it here. Center is Y. Okay, and this one does need a flip horizontal. Why did this one not need a flip horizontal? This one needed a flip horizontal. Okay. L bend, that's with that open. Both variations off of U. We already have the singles. Take these. Tile art, man. Tile art. Get rid of the little joints here. Okay. Take that. And we remove one, that one, that one, that one. Here. We have permutations for that piece being removed. Or one more off of this one. I'm waiting until I figure out how I'm waiting to figure out how much it will take until I give up on this. Because I'm being super detailed here. Okay, if we subtract one of these, we get the L shapes. I think this is all of them. I think this is all of the rational ones. Actually, no, we need to carve these up a little bit more for the interiors. Do I need all of these? I mean, I'm potentially vetoing myself. One moment. I feel like I'm going too far. Let's see here. Let's see here. Top stuff. Do I need budding diagonals? So it's the diagonals. The diagonals are what will throw us off. Don't want tutorial videos. I don't want downloadables. I want examples. I'm looking stuff up here. Nope. Hollow interior with so that's interior corners, convex concave corners. Okay, we are going to go for direct adjacency only. Convex concave corners. No diagonals. No isolated diagonals. So stuff like this is right out. These are not isolated diagonals. These are still connected. These are still connected. These are connected. These are not. These are not. These are not. Okay, so there's still permutations off of some of these that we would need to account for to get those variations. But we could still intercept further because we're largely accounted for here. So what would have to come off of these to make it make sense? This one can be adjacent to an edge. This one can be adjacent to an edge. So, like, this one can abut one of these. Well, it would be like this one. That creates a wider gap. So that lets us have a flat surface adjacent to a concave one. But this is only valid if there isn't one up here. But why wouldn't this one work? This is a diagonal corner. So, I'm sorry, this one relies on a diagonal corner. It would effectively be adjacent to this one, but it would need to join diagonally here. And so I don't want this one. So this one creates a hard gap here and here, as well as here. But it adjoins diagonally only on one edge. I want to avoid diagonal only, where there is a connection between this tile and this tile, but there's no intermediary. We can create map generation rules that would do this. Where it doesn't care that there is a diagonal corner. Only that the associated corners are filled in. We would need to be very specific how we build these out. So we get rid of U. This is, again, diagonal corners. It creates a ramp pattern. It creates a diagonal curve. This one is closer, but for the time being, no. Similarly, these. Sorry, existing ones. Again, diagonal corner, diagonal only corners, diagonal only corners, more diagonal onlys. Even the U-bend. This is a single tile embedded. I think this one is actually valid, but we can still avoid it. How would we actually do that, though? Let's keep these in here. Let's get rid of you. We will add complexity as we need to. So generally, you would present these like this. Set it up that way. How can we organize this so that it's not terrible? So we can't quite smush it in there. We want to minimize wasted space in this. And right now, there's plenty of wasted space. And we will need more of these. Okay, so there's more of this. There is essentially T-junctions. That. These exist. They could be adjacent to an edge. This creates a backed T-junction. It is a sibling of this one. where we are connecting in that fashion. Okay. Then this one should have some siblings as well. So we have this pattern here. Let's move them so it's visible. Okay, so this is a concave corner that connects to two straight lines, effectively. So we take this again, and now we are going to crop this piece, this piece, this piece, this piece, and we are going to horizontal. That gives us both variations of this. If we crop one more off, we have a basic concave corner here. Now, I suddenly feel like the U-bend is relevant, which makes the L-shaped ones relevant. Because those connect to a U-bend. These assert that it's always a full tile coming in. A U-bend tile would be this guy here. So what about this one would be necessary? That would be... We'd have like a gray block like this, and it would have an open space like here. So in general, it would connect to blocks that are like this on edges, but just as likely, if I don't want to have this pattern here, where it is a tile that only touches a corner without siblings here, so it doesn't have something left and right, it only has a diagonal. So these are corners only kind of jobbies. Which gets us into patterns like that. So these are when you have concave tiles. This one is more like this. I think Sammy's yelling at me. Or just as much, I have this guy and then I take a little divot out of it. That is what this tile is like. If I wanted to have a U-bend, what I could do is have a tile like this and a tile like this. One there. So this creates a U-bend. If I have diagonal connections, then I need to account for things like this. This is a very different pattern, where I'm dealing with like half of tiles. I feel like I want to deal with full tiles. So in that vein, and when I say full tiles, I mean this is a full tile. If I have classic shadow on it, we do that. So that's a full tile. Let's then pretend if we have like this one, so we have these kind of T-junction tiles. What that amounts to is whether we open an edge or not, like that. So anytime there's a yellow, that is an open edge. So an L joint, like this one, is this, where I have these open edges. But I have a hard line here. There's nothing connected here, and this dot says there's nothing here. They're very, very similar. If I wanted to have these as clean as possible, there'd be heavier lines here, so that this dot would be more emphatic. You'd round the corners on the tile more. To really emphasize that and that. Not quite like that, but yeah. More likely it'd be you put some decal in the middle of it, like this, to call out that it's an object, you know, that there's some elevation to it. So then when I open a side and leave that in there, I can remove some of the decals or something like that. Or add other decals that will cause it to join together on the relevant sides. But diagonals create circumstances where you kind of expect to have tile patterns that are more like these things, where I have these gaps in the tile that there's still going to be something there most likely, but it's this tile connects to it only on like this edge and this edge. So this tile knows that it has something here, something diagonal here, diagonal here, diagonal here, here, and nothing here. That's where we get into extreme permutations on them, and I feel like I just want to try to avoid that as much as possible. So this tile, if we look at what that one would look like, so take our main dark color here. We are going to put a tile here. We're going to put a tile here. I'm gonna move these out of the way. And we are going to put tiles here. Here. Like that. So what would this one look like? We would need some sort of indicator that there's a hard line there. This one could extend out this way. This one would probably have its bright line there. This one would have its dark line here. I think we would end up with that. And then it would probably have a dark side right there. So then we could have our pips still to show the corners. But that's the differentiation with this tile, where this central one doesn't change a lot. Now, that's because of the nature of this. If I, again, round off the corners more, maybe give them more like this, so then we have the two teeth there. If I round that off, then it's much more apparent when I do that. So let's go with the classic kind of Zelda look. Where we have this little marker here, this little marker here, here, and here, here, and here. So a regular tile would look like this. And you can get variations on this, but this is, again, kind of a classic design. It creates kind of a raised... this uses the Zelda POV, which is weird. You could have different colors inside that to shade it further. But I'm looking at it from all angles, just like in most of the Zelda dungeon rooms. 2D Zelda. You would see the walls as if you were looking down and facing them from every side. So you have kind of a fishbowl panopticon kind of view arbitrarily. So if I had something like this, now things are different. This interior tile is much, much different. We would have things like this. Where I have an interior corner. So this whole shape would extend out. So we also get a little bit more detail as a result of that kind of pattern. Where we come in here and here and here. It would be... pixel layouts. So these little guys are sprite code layouts, or sprite sheet layouts. And what we're talking about is which one of these are relevant? Which ones do I want to have? I think we still need a lot of these. Oh. My bad. I was looking up stuff. And then yeah. Oh. Womp womp. Oh dear. Oh dear. Okay, it's clearly getting late. We've been going for over 9 hours. Okay. Okay. So I will dither about that some more before the next code stream, hopefully, and we'll be able to make a decision. I want to minimize the amount of tiles that I have to make and maintain. But I also want to make sure that it looks good, you know? That independently the tiles can look okay. There are some tricks that I do want to look up and make sure that I've got some flexibility. We're avoiding just rotating the tiles. We are going to have a pseudo, like a perspective effect on them. Think games like, again, Dragon Quest, Earthbound, that kind of thing. There is the vibe that you're looking down and into the world. So we're not going isometric, but it's kind of tilt your POV down a bit. You don't see the diagonal, but you do see some of the side. Which is why, again, I want to focus on cardinal direction with some concession for interior diagonals. Like, the diagonals should not be sitting by themselves. If they are, that tile is in a wonky position, and isn't necessarily going to work for us. But we'll see. We'll see. All right, folks. I hope you had a good time watching with us tonight, especially the periods where I was just talking into the void with nothing on the screen for you to see. Well, I mean, the cat was there. Mason was there. So, yeah. You at least had that. But if you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All that stuff does help the channel grow. If you'd like to consider financially supporting the channel, you can do so through platform-specific means as... Let's see, let me make sure that I account for all those folks. I'm going to thank them once more, as Tass, Wizzy, and Parakeet did today with bit-related effects and subscriptions over there on the Twitch side. Thank you again. But with all that said, I hope the rest of your day is good, and I will see you next time. Tomorrow we are going to be doing some blueprints again. So hope to see you there. Good night, everyone.